Recording has commenced.
Matthew, you might, I don't know if as a panelist, I'm talking to everybody or just to you, the panelists, but um, if you want within the WebEx environment, if you're not aware that you can go to the View tab and click on View Full Screen. And if you have multiple monitors, it allow you to see what's being shared in one of your monitors, and then the chat and all the other components of the that take up screen real estate. You can push those over onto your other monitor if you're wanting to look at what's being shared a little more completely. Just to give you that hint if you're in your WebEx environment.
And Brian, everybody could hear you, so I think they all heard that.
Fine, great. I told everybody how to do View Full Screen if you care.
Good morning, and yes, this webinar is being recorded for future viewing and to share with those who may not be able to attend today. So this webinar is being recorded. I am seeing 12 o'clock. We'll just give it another minute or two before we get started. My name is Matthew Lloyd again, and I will be moderating the EMDQ webinar, and we'll begin shortly. We'll just give some people another minute or two, and then we'll begin with our introductory. All righty. So good morning, everyone. Good afternoon to those on the East Coast. Welcome to the 17th DoD Environmental Monitoring and Data Quality Workshop webinar. This is the opening for the 2021 year. So I just wanted to welcome everyone. And real briefly, I have the agenda here for just reference as to what's going to be discussed during today's webinar. But initially, what I would like to do is just briefly go over some of the functionality of WebEx. Please utilize the chat functionality for technical issues. If you're having trouble hearing any presenters or if we're seeing any systemic issues with the software, please use the chat functionality as best you can to address those items. Questions regarding the presentations will be submitted via the Q&A function. Video and audio functionality will be disabled for this event. Each session has a specific time allotted for the Q&A, and at the end of the presentations, we'll go through that. And then also at the end of the meeting, we also have some time left over to address any leftover items. So presenters may choose to utilize the polling feature, and that'll pop up on the right part of your screen. You'll see that as we get into it. And also to be noted, this webinar is being recorded. So this will be available for future reference, and it will be posted on our Denix webpage, and it'll also be emailed out to the large distribution list once it is posted. For questions and answers, when submitting questions during the Q&A, please select the drop-down box within the Q&A panel and select all panelists to ensure that your question is viewable by all panelists. And lastly, as for functionality, following the conclusion of this event, you will be directed to follow a link to a Google form that you will use to anonymously submit your feedback regarding the event. The EDQW utilizes this feedback to assist with planning future events, so we really appreciate everyone's feedback. If you are unable to access the link following the conclusion of the event, an email containing a link to the same poll will be distributed following the webinar. So with that, I'm going to go ahead and pass presenter over to Dr. Jordan Adelson.
Perfect. Thank you, Matthew. So I'd like to take this opportunity to welcome everybody to our 17th EMDQ. And so if this slide looks familiar to you, it's because this is pretty much the exact same slide with the dates updated from last year. And so typically when I prepare, obviously for the next year's EMDQ, I look at last year's slide deck and sort of break it out. And it really sort of was quite interesting to look at last year's slide deck and see this opening slide where we had made that decision to shift from a face-to-face meeting, to this web-based format. And so we've had, I think all of us, a challenging year with the ongoing of the pandemic. And so, you know, the EDQW has strived to obviously be and continue to be productive in this vein. But one of the things that sort of came out of, you know, this situation is that, you know, no matter what we do going into the future for the EMDQ, and I'll talk a little bit about plans for next year, you know, we found this format to be very, very helpful and useful in really getting our message out. We sometimes overlook the fact that some folks just have a hard time traveling, even under the best cases and best situations, due to a whole host of issues. And so we're sort of committed at this point to, no matter what we have going forward, to have some component of the MDQ exist in this format. So our hope is to continue this type of stuff so that we can get the type of outreach that we're really shooting for. And we've gotten, like I said, a lot of positive feedback on this in this past year, and so we continue to sort of, you know, embrace these tools and carry them forward. Although I think it's fair to say that most of us sort of hunger for a face-to-face meeting, and our hopes are that that will happen in the near term. So this is just an agenda for the webinar today. So after my introduction, we're going to go through some real basic updates on what the EDQW has really been working on, and some things just that we thought that you folks would be interested to hear from. So these are some of the subgroups giving updates. And so Melissa Wingard, who works for my office, is going to be giving an update on the DoD ELAB. She'll go into obviously lots of details and give you guys some information, but these are all sort of short 15-minute presentations. And then Ms. Janice Woolley, who works for us, will give you an update on PFAS, which I'm sure you're very, very interested in. Just sort of give you a status update of where things sit and what's going on with method development and the like. And then following that, Melinda McClellan, who works for the Army, is going to be giving sort of an update now brief of our data review and management subgroup and their efforts with the data validation guidelines and our data usability guidelines that we're working on to pull things together. And so that will sort of give you that kind of a basis of what we're working on as EDQW. And then we're going to transition into sort of the main topic focus of this webinar, which is sort of going through incremental sample methodology. So as many of you know, hopefully, ISM obviously has been around for a while. The ICRC just not that long ago just released an update to their incremental sampling methodology and their guidance document. And so we thought it would be a good idea for us to sort of touch base back on the topic and go through this presentation. So Ed's going to sort of lead this discussion, and we're fortunate to have these distinguished speakers in that sort of second group to sort of focus and talk through some of the methodology and how we can sort of use this as an everyday tool, how it can be utilized and carried forward. And then Ed's going to sort of wrap this up and give kind of the EDQW's sort of perspective and what we're working on, our initiatives associated with incremental sampling. So you guys can sort of address that and carry that forward. So this is just my standard sort of overview of what the EDQW is, just so that in case there are folks on here who haven't, heard us speak before, heard me speak before, sort of talk about it and give you an idea of who we are as the host of this webinar. So, I serve as the chair of the DoD's Environmental Data Quality Work Group. I also am the Navy's principal. The Air Force's principal is Seb Gillette, and the Army's principal is Brian Jordan. And so we've got the service principals that sort of make up the leadership of the EDQW, and then we've got participation from each one of the services on our technical work groups and sort of helping us out as we go through things. And we really have the overall mission of developing and recommending policy related to sampling, testing, and quality assurance for environmental programs, with a focus to eliminate redundancy, streamline these programs, improve data quality, and promote data integrity. We spend a lot of our time sort of coordinating the exchange of information among the DoD components. This is an ongoing thing, right? New things come up, and we really want to be as consistent as possible across our board. And for us, that's helpful, right, to have a consistent approach, but also for the folks that provide service to us. A lot of the folks on the line I know are contractors and laboratories, and so as consistent as we can be, right, in what we're communicating, the easier your job is to meet sort of those needs carrying us forward. We develop DoD issuances to implement environmental quality systems to promote cost-effective government oversight, and obviously this implementation and provide oversight of the DoD ELAP is a major function that we perform. And so the DoD ELAP, as I just mentioned, Alyssa's going to give a lot more details on this, but the program really started in 2009 and is a great example of just sort of us working together, as one department carrying things forward, right? We initially, sort of in the 90s, identified the fact that late 90s, had to really come together on requirements for laboratories, especially in the cleanup side of the house. So around 2000, we released the first version of our DoD QSM, so we're all using the same requirements. And then, as time went by, it took us a number of years really to sort of come up with one consolidated program, which is the DoD ELAP. And really, it's the use of these third-party accrediting bodies to do our assessments has been a tremendous benefit, and we really look at this program as a really pretty substantial success. And it really focuses on this promotion of reciprocity, this fair and open competition. It streamlined sort of the procurement process, and promotes this collection of data of known and documented quality suitable for their intended uses. That's really what the focus of what we're trying to get to is. And it really allows us to focus our attention on project-specific reviews, which is really what we should be focused on. Another sort of major initiative that the EDQ is involved with is this Intergovernmental Data Quality Task Force. And this is a group that's actually led by the folks at Office of Secretary of Defense. I'm the principal DoD representative, and the EPA, with the principal representation coming out of EPA's Federal Facilities Restoration and Reuse Office, FFRO. And so what this allows us really to reach some some high-level consensus on data quality issues. So it's similar efforts to what the EDQW is working on, but really with some regulatory buy-in to these products, which really helps us be successful with their implementation. And we really do reach a lot of common ground working with the IDQTF. And so, over the past few years, we've really been focused on the munitions side of the house, munitions cleanup, and really focused on that. We've got a couple of initiatives that we're working on that we're really trying to expand out to be more IDQTF, just beyond what the EDQW is doing, and really engage the regulators and get some buy-in on what we're working on. And so we've got some big plans to sort of work on that. And one of the interesting things that has occurred is that, back in the 2000s, early 2000s, when the IDQTF was really kind of getting going, we had pretty significant participation from the Department of Energy. After 2005, that really dropped off, and there really wasn't much DOE involvement. But DOE has re-engaged, and so we're really excited about them sort of being involved and sort of helping us as we sort of engage and expand on what we've got currently working with our friends at the IDQTF. And so, this is my big reveal, as big reveal as I get. So we're planning for the 18th Environmental Data Quality Workshop. And as you can see from the graphic, we have a week selected, the week of April 25th and 29th in 2022, back at Shades of Green. So obviously everyone get used to hopefully seeing Mickey at that time frame. And so we're very excited about the prospect of having this face-to-face meeting. So this is what we're planning on doing. We've already got that week reserved. It will not, obviously, it'll be the same sort of schedule we've done in past years. That's at least our plan now, so it won't take up the entire week. But this is sort of a very early save the date as a sort of concept for us. And as I said, we've really found over this past year the benefit of having these webinars and utilizing them. And so even, I am fairly confident that we will be able to have a face-to-face next year. We're going to continue to have some outreach in some format that sort of mimics what we're doing here today, so that, like I said, we can reach a lot of folks and a lot of people carrying this forward. And then finally, this is going to wrap me up. Obviously, any questions or issues with EDQW, please feel free to contact me. My email is on the slide, or you can obviously go to our Denex website and see where all our products and information is posted. But I'll also make a plea for the folks to please, to please fill out the survey that Matthew mentioned up front. It's really important for us. That feedback is really helpful as we go forward, and that's really how we've identified the sort of benefits that we've seen from these webinars and help sort of direct us. So we really do look at that feedback. It really does help us as an organization, and our goal is to communicate the products and stuff that we're working on, and it only helps us if you provide that information. It helps you because you then tell us the kind of things that you'd like us to be able to share with you. And with that, I'm done, Matthew, and I think we can bring up the next slide. And so,
thank you.
Alyssa, I was just going to introduce you. This is Alyssa Wingard. Like I said, Alyssa works from my office, and she's going to be giving you an update on DOD. Sorry, Alyssa, take it away.
No worries. Thank you so much, Jordan. Before I start off, I, for one, am really excited about the potential of holding a face-to-face workshop. Again, next year, I think it's really valuable time when we can all be in one place and network together. I know we've all missed that interaction amongst our colleagues, so I am thrilled that we'll be able to do it once again next year. And in addition, I just wanted to give a special thank you to Matthew Lloyd of the BMT team. He really does a lot of work behind the scenes with our outreach and with our webinars. So thanks to Matt for making this run smoothly. With that being said, I'll jump right into the presentation. So a few objectives I'll be covering today. The first will be the status of the DoD ELAP. Secondly, I'll be talking about remote assessments and our return to normalcy, which I think we are all excited about. And lastly, I will give you an update on where we are with QSM version 6.0 development and give you a little insight into some of the exciting changes we're making with that document. As of May 3rd of this year, this slide depicts, as I do in most of our workshops, the status of where we are with the laboratories that are DoD ELAP accredited. as you can see, there are currently 82 laboratories accredited for the DoD ELAP. If you look at the very bottom row, you can see that over time, that number has really stabilized. We're up 2 from last year. In addition, you can also see that we have 3 accrediting bodies. 2 are a little bit higher in numbers than the 1. But as we all know, laboratories have a choice as to who they can go to as far as their accrediting bodies based on price, service, et cetera. So I'm excited to see that we are holding steady. And for those of you that may be a little bit newer to the DoD ELAP, before the inception of DoD ELAP in 2009, there were only 44 laboratories in the program. So the DoD ELAP certainly has opened up room for more laboratories, room for more competition as well. So we're excited to see that number, and we're glad to see that number of laboratories participating in the program. From what we can see, they're all providing a quality output for the program and for the DoD ELAP. PFAS continues to be a big issue. I wanted to share with you the number of laboratories that are accredited for each matrix. You can also find this on our DENX website as well. Currently for AFFF, the formulation, we have 5 laboratories. Aqueous, we're showing 28. And if you think back to the previous slide, we had 82 laboratories total accredited in the DoD ELAP program. So roughly a third of our laboratories now have PFAS capabilities. That is about double from what the number I showed you last year was. So we've seen a lot of people enter the market over the last 12 to 18 months. We are showing 26 laboratories for solid, and lastly, 5 for tissue analyses. And I would anticipate, based on the feedback that I get and what I see coming up on the schedule, that these numbers might continue to grow just a tad. We don't see the PFAS market going away anytime soon, and Janice obviously will speak more to that in her presentation. As far as the methodology they're accredited to, the last slide was the table B15, which is the undeveloped method, but the DoD requirements at this point. However, this slide is showing you the EPA methods, primarily the drinking water methods, and how many laboratories we have accredited for each of those methods. The one thing I wanted to note on this slide, we all are familiar with the fact that with EPA drinking water methods, they are prescriptive methods. You are not allowed to deviate from those methods. So you'll see on this slide, EPA 537 mod. The question you would ask is, why would there be a mod when you're not allowed to deviate? The reason being, the 2 laboratories that have this on their scope of accreditation, it is listed as mod because they have just added 2 additional or 4 additional analytes to the method. So it's just an analyte thing. They're not doing anything different in the method other than adding some analytes, which technically it makes it a modification. So that leads us to where we are with potential changes to the DoD ELAP program. As I've said, it's stabilized over the years, but we're always striving for improvement as well. Some of the things we've seen over the past many years of the program is that some of the accrediting bodies are allowing extensions to be granted. That's really not showing us a level playing field. When one laboratory may have an extension granted that allows them not to have an on-site as often as others, I'd like to note here, there is one accrediting body that does not allow extensions to be granted at all. So we are really tracking that closely. What I would like to say here is that we understand the challenges of COVID as well. And with those challenges, we have been more understanding of extensions. But as we move forward, as restrictions lift, we are going to be discussing this heavily within our EDQW meetings, and we are potentially going to change the DoD ELAP conditions and criteria to not allow any extensions. So that should be noted. The other thing we spend some of our time with our oversight on is tracking down assessment reports from the accrediting bodies. We are considering putting in some strong language into the conditions and criteria with the ABs that would require all assessment reports to be received within 14 calendar days. And at this point in time, we do not plan to open up the DoD ELAP to any other ABs at this point. We have a stable group of ABs. They're able to manage the workload at this point. So at this point, we don't see any changes being done to that. Currently, all of the accrediting bodies are doing remote assessments. Obviously, we were in some type of a lockdown mode for about a year. However, with the vaccinations underway, we are beginning to see some return to normalcy. Some of the normalcy that we're seeing being returned is Louisiana is now requiring on-site assessments. California is requiring on-site assessments. And Florida is going to be doing remote assessments until at least July 1st, 2021. Now, these statements obviously are fluid as things open up more. We may be seeing more states. Someone just messaged me and said Texas is also requiring on-site as well. So I think as the weeks and the days move on, we are going to be seeing more states opening up for on-site assessments. As far as the Department of Energy is concerned, they have issued a memorandum, and what their memorandum has said is that they will require all laboratories to have an on-site within 6 months of restrictions being lifted if the laboratory had a virtual assessment in lieu of their normally scheduled on-site. So what they're saying here is that if you had a virtual instead of what you should have had as an on-site, they're going to require the accrediting body to come in within 6 months of restrictions being lifted. So that will affect a small portion of their laboratories. The next thing that we're seeing and hearing right now is that all drinking water laboratories are currently required to have an on-site. So what are our accrediting bodies doing as far as going back on-site? As far as the EDQW stance on this, we have always allowed the accrediting bodies to follow their own procedure. They're ILAC signatories. We tell them they are to perform as ILAC intends them to perform during this pandemic. So whatever ILAC is allowing, we will also accept that as well. But we are seeing some of them return to normalcy. PJLA has stated that they are going to resume on-site in July. ANAB is hoping to go on site in July as well. And from what I've been told, HULA is going to be conducting remote assessments until September. So those of you that are involved with laboratories, most likely if your assessments are coming due, those should start going back to an on-site assessment. Having witnessed remote assessments, it has been really, really challenging to both the laboratories and to the accrediting bodies. The technology can be really spotty. You can only see so much. I think it's been an extra amount of work on the assessors and the laboratories. So we're hoping that, once we go back on site, everything will go back to normal, and hopefully we will have not seen any decline in quality because of having remote assessments. So the last portion of my presentation today has to do with QSM version 6.0 development. We have a team of people that we work together on. It's a joint team comprised of Army, Air Force, Navy, Department of Energy, and contract support. You can see the list of the names that participate in the group. On this slide, I won't go over them in depth. As far as developing the QSM, COVID has really impacted our speed on this. Prior to COVID, we were having 2-day face-to-face meetings every few months or so, and now we have really been slowed down. What we have been doing since COVID, we have 3-hour teleconferences every 3 weeks. It's grueling. As those of you who spend a lot of your time on teleconferences know it's much harder to get things accomplished when you can't get a read of the room, you can't, project clearly in front of people. So we've had our challenges. We are still plugging forward though. We are hoping to resume face-to-face meetings in the first quarter of 2022. And lastly, we expect this document to be completed sometime during calendar year of 2022. Obviously, if we can resume our face-to-face meetings in the first quarter of 2022, it may speed up our process. So what have we been working on with the development of QSM version 6? What kind of changes will be coming down the line? We are aligning the document to ISO 17025 2017 in regard to format and numbering. So it will follow the format and numbering of ISO 17025. We are planning on adopting TNI 2016 in all of our modules. However, we may not include all text from TNI 2016, and we have received permission to modify some text if we denote it as being modified. For those of you that are users of this document, this may make you happy. We plan on, in conjunction with TNI, having a combined version, which would include TNI, ISO 17025, and the DOE language of QSM version 6 to be available for purchase upon publication. So that will help you with having to have 3 documents in front of you while you're trying to interpret all the requirements of the document. So what are some of the things that we are proposing potentially to change as we move through this big revision, this big undertaking that we're doing? We are certainly evaluating the LOD-LOQ scheme. The early indication of our subgroup, it is not going to change to align to MDL2. The subgroup does recognize the challenges MDL2 has brought about with our scheme, however. With that being said, we may eliminate the 2 to 4 time requirement of the LOD, and we may not require the LOD to be less than the LOQ. So those are some of the things we're looking at. No in-stone changes yet. Appendix A, the reporting section, is being thoroughly evaluated. We understand there are challenges with limb systems. We're trying to make what is in the reports to be relevant to the end data user, to be useful, and not to put undue burden upon the laboratories. We're also going to make sure that that text in the module aligns with Appendix A so that you don't have to flip back and forth. Each thing aligns properly. We are reviewing all Appendix B tables against the most current EPA method, and we will align all the requirements in those Appendix B tables as well to obviously the most current EPA method or to what we feel is the most stringent in some cases. We are going to remove table B23, which is going to make a lot of you excited. However, we are currently conducting an ISM surrogate research study. I reached out to all of our DoD ELAP laboratories to ask for participation in that study. If for some reason you did not respond back saying that you wish to participate in the study and your laboratory has capability, feel free to email me and I will get you into that study. Well, we're going to be populating some new tables in the QSM. We will have a table for LC-MS-MS for agent breakdown products, a table for 8260, 8270 SIM, some potential ISM tables, a table for 1668 PCB congeners. Please note here, with 1668 PCB congeners, all analytes need to be spiked. That is a common thing we are seeing when we evaluate data that is not happening. It is a requirement. Table B15 will be revised. It will be more in line with the EPA PFAS efforts, and Janice will speak to that after me. At this point in time, the Appendix C LCS study will not be updated. Additionally, some of the other things we're looking at, definitions are going to be requirements. We are working very hard to ensure all items in the QSM are auditable. Documents versus records, the nomenclature is being addressed in all sections. We are trying to minimize DOE-only requirements. We see ourselves as a team with the Department of Energy, and we want to align our requirements to the best of our ability. We have done major consideration of the ISO 17025-2017 risk paradigm. You'll be surprised when we finally roll out this document how we are going to be putting some more risk back on the laboratory in some instances. The subgroup is focusing on data quality, usability, and defensibility when it comes to the requirements of the document. Any outstanding items from QSM version 5.3 development will be addressed. We had a long list there because, as you know, QSM 5.3 was a bridge document just to get us in compliance with 17025-2017. As you've seen already, we're rolling out sections for comments that are, as they become available. We've already rolled out modules 1, 3, 5, and 7. And like I said previously, we anticipate the publication to be sometime in 2022. I would love to see it align in some shape or form with the workshop next spring. That is my goal, and we would love to be able to do some training there. That being said, you guys have my telephone number, my email. Feel free to reach out to me with any questions or if you need more information. Thank you so much.
Thank you very much, Alyssa. I believe we are just a little bit behind schedule. So if you have any questions regarding Alyssa's presentation, please submit them, and then we will circle back to those when we get to the open forum. So with that, Jordan, do you want to go ahead and introduce Janice?
Sure. And so now Janice Willie will be giving you an update on our efforts with PFAS and sort of where we sit. So Janice, please take it away.
All right. So once again, I'm here talking about everyone's favorite subject, PFAS. Obviously, I can't cover everything exciting happening in the world of PFAS today, so I'm going to give you an update on the current state of PFAS methods, but my main focus will be on DoD PFAS method initiatives, especially the 1600 series method I spoke to you about during last year's EMDQ webinar. When it comes to published EPA methods, some progress has been made in the past year. A new version of 537.1 was issued to make some clarifications and corrections. This method, along with EPA 533, have recently been proposed for use under UCMR 5. SW846 method 8327 still has not been issued as a finalized method, and as I stated last year, is considered by the DoD to be a screening method and is not to be used for the collection of definitive data for the DoD. And lastly, this year, we actually got a new method. EPA's draft Other Test Method 45, or OTM 45, contains procedures for sampling and sample preparation and analysis of air emission samples from stationary sources. And that's it for EPA methods. We still have method gaps with respect to media and analytes. So helping to address this gap is the 1600 series method the DoD is working on. The Strategic Environmental Research and Development Program, SERDP, has funded and led an effort validating a method based on a method developed by a DoD ELAP accredited laboratory, SGS Axis, through inter and intra-laboratory validation studies. The method targets 40 PFAS in groundwater, surface water, wastewater, landfill leachate, soil, sediment, biosolids, and tissue, and utilizes 24 extracted internal standards, EISs, to perform isotope dilution quantitation. Samples undergo wax solid phase extraction and cleanup steps before being analyzed by LCMS-MS. The QC parameters of the study are consistent with those required by DoD and EPA Office of Water. Here's the analyte list included in the validation studies. It includes all analytes included in EPA 537.1 and 533 and SW846 method 8327, as well as a few extra analytes thrown in for good measure. Most likely, the draft method will include media-specific analyte lists, as all analytes do not perform the same in all media. The inter and intra-laboratory validation studies are very similar in structure. Both include initial demonstrations of capabilities, initial precision and recovery studies, MDL studies, and limit of quantitation verifications in the initial phase. The field sample analysis phases included in both studies currently contain the same number of samples and replicates. Each include 7 samples each of wastewater and soils and 3 samples each of all other media. Each are currently analyzed a total of 12 times, 3 unspiked, and 9 spikes spiked at 3 different concentrations. The intra-laboratory study was conducted by SGS Access, and the inter-laboratory study will consist of 2 state laboratories and 8 DoD ELAP accredited laboratories. There are a few differences between the 2 studies. For starters, the intra-laboratory study also includes a holding time study for groundwater, soil, sediment, and biosolids. It did not include wastewater and surface water, as the project team accepted the previously published holding time study authored by SGS Access for these media. Another big difference is that the samples in the intra-laboratory study were homogenized and spiked by SGS Access, whereas for the inter-laboratory study, ERI waters will homogenize and spike samples prior to shipment to the participating laboratories. And here are some basic requirements for the validation studies. To be clear, I'm not saying that this is what is going to end up in the draft 1600 series method that will hopefully be published by the EPA. They have the final say of what makes it to that published method. For the study, aqueous samples are extracted using wax solid phase extraction followed by carbon cleanup using loose carbon, not cartridges. This is because we found loose carbon does a much better job eliminating interferences. Soil, sediment, biosolids, and tissue are extracted using solvent extraction followed by cleanup using wax solid phase cartridges and loose carbon. The study requires a method blank laboratory control sample and limit of quantitation verification sample be prepared with each preparation batch. The ion range of the mass calibration and mass calibration verification must bracket the ion masses to be monitored by the method. A minimum of 6 calibration points are required, with at least 5 of them within the quantitation range. Analytical sequences include instrument blanks, instrument sensitivity checks, calibration verifications, and qualitative standards. When analyzing tissue samples, a standard of TDCA is required to verify its complete separation from PFAS, as this is a known PFAS interferent. Transition ion ratios are required to be monitored, and the recovery of the EIS compounds is determined using NIS responses. All of the analyses included in the intra-laboratory study have been completed. So next, I want to give you a sneak peek at some very, very preliminary data. Keep in mind, this data is compiled without elimination of outliers due to such things as failing ion ratios and high concentrations of native samples. So first, let's look at the holding time study results. This graph shows the mean recovery of all 40 PFAS in samples stored at 4 degrees C and -20 over the course of 90 days. From this graph, you can see the only media that was significantly affected by temperature was groundwater. It's thought that the main contributor to this trend is the transformation of precursors. Next, we have matrix spike results. The average of the native concentrations of the 3 replicates of each unspiked sample was subtracted from the 9 matrix spike results, and the percent recoveries were calculated. For this heat map, the mean recovery of each analyte was evaluated against acceptance criteria of 70 to 130% recovery. So a green block indicates it met the criteria, red block means it did not. As you can see, the mean recoveries for all analytes were within this criteria for soil, sediment, and groundwater, and only 1 analyte exceeded the limit for surface water. So the expected trends of the more complex matrices, the more exceedances, proved to be true. Obviously, when using isotope dilution quantitation, you have to also evaluate the recovery of the extracted internal standards, or EISs. This heat map shows the mean EIS recoveries for all samples as compared to the acceptance criteria of 50 to 150% recovery. As you can see, the mean recoveries for all EISs were within the criteria for surface water, sediment, and groundwater, and only one analyte exceeded limits for soil and landfill leachates. As expected, most of the exceedances correlated with the exceedances documented in the matrix spike data. Next up, we have the AFFF method initiative. This effort was funded by NAVC as Navy is the owner of the performance specification for AFFF concentrates. This military specification, or MIL-SPEC, has been amended over recent years to include restrictions limiting the amount of PFOA and PFAS that is permitted in an AFFF concentrate. This limit was not based on a desired limit, as we really don't want any PFOA or PFAS in our concentrates, but rather it was based on the achievable limit of quantitation of the existing methodology. That limit is less than 800 ppb PFOA and 800 ppb PFAS. The method validation effort, validated a method designed to achieve lower limits of quantitation for 33 PFAS, including PFOA and PFAS, in AFFF and alcohol-resistant AFFF concentrates. It is very similar to the 1600 series method and can achieve a limit of quantitation of 25 ppb or less for most analytes. Inter and intra-laboratory validation studies have been completed, and the method is currently in review. This method will be required to demonstrate compliance to the future revision of the MIL specs for AFFF. And lastly, the newest initiative, the evaluation of total organic fluorine in firefighting agents method. This effort is funded by CERTUP and is led by the Naval Research Laboratory, NRL. Why does DoD need this method? That's really simple. The 2020 NDAA, or National Defense Authorization Act, prohibits the procurement of AFFF containing greater than 1 ppb of PFAS after October 1st of 2023. So we're moving away from fluorosurfactant-based AFFFs to other firefighting agents that are yet to be determined, as we currently have no means of quantitating total PFAS in these yet to be determined agents. The method is most likely to use pre-treatment and extraction techniques to separate organic from inorganic fluorine potentially in these agents. The determination of organic fluorine will be done by combustion ion chromatography and IC. While CIC has been used to evaluate some AFFF formulations and other media, the limit of detection and quantitation that have been achievable are magnitudes greater than what is required by the NDAA. This and the fact we are developing a method for media that is really yet to be determined are most likely the biggest challenges in this initiative. The DoD is definitely not alone on the PFAS method development front. The EPA has a number of methods currently or soon to be in development, and as does USGS. Here are just a few. And lastly, I wanted to update everyone on the status of some of the materials needed for current and future methods. More and more PFAS standard mixtures are becoming available, while the number of available quantitative isomeric mixtures is holding steady at 4. FYI, all the standards required for the 1600 series method are currently available right now. So there are some CERTUP funded standard development projects that will be relevant to other future methods. The first is a NIST project that is creating 4 AFFF formulation reference materials. Obviously, this would be applicable to the AFFF method I spoke of earlier. They also are creating a PFAS mass spec library that will be applicable to non-targeted PFAS methods that are currently in development by other agencies. Obviously, there's a lot more going on in the world of PFAS, but hopefully I've highlighted some things that will prove to be helpful to you. With that, I thank you for your attention, and we'll take some questions if there's time.
Thank you, Janice. I think we don't have time now, but we will push those questions. If you have them, please submit them. We will come back to those questions when we get to the open forum section. With that, I believe we will be going to our next presentation, which will be the data review and management subgroup. So Jordan, go ahead.
Yeah, so I'd like to, yeah, absolutely. So Melinda McClellan, who serves as the chair of our data review and management subgroup, will be talking through some of the efforts they've been working on associated with some data validation guidelines and what they're working on for data usability. With that, Melinda, please take it away.
Yeah, hi, thanks. So as Jordan said, I am the chair of the data review and management subgroup. And I'm going to take just a few minutes to give you an update of what we've been working on and what you can expect to see here in the near future. So I want to start with a poll. Hopefully everybody has their WebEx open and they can see the poll on the side. And so my question is, have you read the data validation module 4 that has been published? And so the answers are yes, no, I delegated it to someone else, and wait, there's a module 4? And obviously my intent here is just to draw your attention to the fact that we have published module 4 and it is out there for everybody to use. So I'm going to give just another minute or so. Module 4 is, if you're not aware, it's the data validation guidelines for GC data. So a lot of what you'll see is similar to what's in GC mass spec, but obviously does not include the mass spec and then includes those things that are specific to GC. I'm going to go ahead and close the poll here. And it looks like of the people that answered, the majority of people said no, but at least they didn't say that they didn't know about it. And about half those actually have read it. So that's good to know that at least most people are aware, and it looks like a lot of people have already read it. So what is our subgroup? Our subgroup includes 10 representatives from the Army, the Navy, and the Air Force, as well as some contract support. As I said, I am the chair. We meet once a week to discuss data validation and about every other week to discuss data usability. The major projects that our group are responsible for are obviously publishing the data validation modules. As I'm sure you are all aware, right now the general guidelines are published, as well as modules 1 through 4. We have started working on module 5, which is going to be ICP mass spec, and we anticipate getting something out there for review here in the next probably couple months, month or two, and then hopefully that will be able to publish by the end of the year. We also are working on developing data usability guidelines. We're hoping to have those out a little bit later this year as well, and those are going to be, it's going to have a general document discussing usability and how those assessments should be performed, and then it's going to follow that with several examples that will be walking through how a project team might conduct those assessments. And then we also do training like these webinars and other outreach. And we do have a webinar coming up that I'm going to talk about later. So I wanted to bring this to everyone's attention. This was published earlier this week. We have revised the blank qualification table. So this table that you can see here is available on Denix. It's the first thing under documents on the side, like on the right-hand side when you open up the home page. It's also available under the documents page. This table replaces the blank qualification tables in modules 1, 2, and 4, but note that it does not replace the blank qualification in module 3. So that's the PFAS module. It doesn't replace the PFAS one, but it does replace the GC mass spec, ICP, OES, and the GC. The biggest difference is this row 4 here. The validation qualifier is now a U or a J+, because in discussions, we sort of determined that depending on your specific circumstances and the relative levels of that blank end result, either of those may be appropriate. So the validator would make a recommendation there. So I want to do another poll. This poll is asking about qualifiers. I'm going to go ahead and open it, and if you're a fast reader, you can read ahead of me, but otherwise I'll walk through it. So I'm going to talk about the difference between the X and the R qualifier, and I want you to tell me which of these are true. There may be more than one. So is it true that the X and the R qualifiers are essentially the same thing? Is it true that the data validator will tell the team which data is rejected by using the R flag? Is it true that the data validator will make recommendations on rejecting by using the X flag? Is it true that the data usability team cannot use the data if the validator qualified it with an X? Is it true that the data usability team determines whether the X qualified data may be used or is rejected? And is it true that all data can be used in some way? So I'm going to go ahead and let the timer run out on this. I've only given it about 1 minute. Like I said, you can choose multiple answers here. There may be multiple ones that are true. And when we're done here, I'm actually not going to give you the answer because I'm going to ask this question again at the end after we've discussed it a little bit to see if our answers have changed. So I'll give everybody a minute to read that over and think about it. Seems like answers are for the most part finished coming in. The timer here is giving it another 15 seconds, so we'll do that. If you haven't sent your answer in, go ahead and do that. All right, I'll go ahead and share these results. You should be able to see them. And like I said, I'm not going to give you the answer, but it does look at this time. We'll talk about it in a minute again. But it does look like the majority of people have answered C and E with B and F coming in second there. And so we'll talk about that some more. So what is the difference between this X and this R qualifier? The X qualifier is used by the validator. The R qualifier is used by the data usability assessment team. The X qualifier is a recommendation by the validator that data should be rejected. Or, in other words, that data has serious quality control concerns and that the data usability team needs to evaluate this data. The R qualifier is this data is rejected. And so the X qualifier, therefore, is not present as the final data qualifier, right? So when you have your final data at the end, you're ready to go out and use this data, you should not be seeing any X's in that. On the other hand, you should only be seeing R's in the final data. Only the full project team, or whoever has been designated as the data usability team, has the full context of the project to know whether that data actually can be used or not. So what do I mean by that? Let's do an example. And so I'm going to actually ask Dr. Allison Cease, who is another one of our subgroup members, to read this example for me and what has come out of validation.
Great, thanks, Melinda. Example 1, a sample was to be analyzed for dissolved metals by ICP OES. The samples were inadvertently not filtered prior to analysis. There was insufficient sample for reanalysis. Then the validation. Per the DoD data validation guidelines, the validator flags the data with X, exclusion of data recommended.
Thanks, Allison. So all of that is pretty straightforward. What happens in data usability? Well, the data usability team got together and they said, all right, we have these X qualifiers, we need to look at them. So they talk about their data, they talk about what it might mean. Okay, so we got what is essentially a total metals instead of a dissolved metals. What can we do with that data? And they determined that, well, if there was a non-detect then in the totals, then that probably meant that there would have been a non-detect in the dissolved also. So we're going to go ahead and use that data with a U flag. And then they said, well, now the ones that had detects, what can we say about those? Well, let's look at our action level. If it's below our action level, then it's probably would have been below our action level if it was just the dissolved anyway. But since we don't totally know for sure what that value would have been, we're going to use it, but we're going to change that X to a J qualifier. We're going to make that estimated. And if it's above the project action level, well, now we don't know whether if you had a dissolved instead of a totals, you would have had a detect that was maybe below your action level. So we're going to say we can't actually use that data. So we're going to flag that. This is what that data would look like. So the sample concentrations are over here. On the left, the project action levels are next to it. And you can see the laboratory would have had a U qualifier on that non-detect. So it would have been, you know, LODU. The validator put an X on all of them, right? Because that's what our guidelines said to do. But then the final DUA qualifier is a U for those non-detects and estimated for the detect below the project action level, and they rejected the data above the project action level. So we're going to real quick do that again. I'm going to have Allison read this second example. We're going to go a little fast through this one, I think.
Sample 2, a soil sample is analyzed for VOCs by GCMS. The laboratory inadvertently did not spike the LCS with one of the target analytes. The analyte was included in the instrument calibration and the qualitative identification criteria were met. Per the DoD data validation guidelines, the validator flags the data for affected analytes with X, exclusion of data recommended.
Thank you. So what does the usability team do with this? They look at it and determine that, well, it was calibrated, and so non-detects are still valid because it wasn't seen there qualitatively. Any of the detects, you know what? We can be pretty sure that it was identified because the qualitative identification is there and it was a calibrated analyte, but we have no idea what the precision and accuracy are. So we're going to make those estimated. This is what that data might look like. I'm not going to walk through this just for time purposes, but you are going to get these slides later, so I encourage you to go look at it and see how these qualifiers sort of progress from what the laboratory provides to the validation to the data usability assessment. So hopefully with that, I'm going to open up this poll one more time, the exact same poll you had last time, so I'm not going to read through these answers again. But with that, what do we now think about what is true about rejecting data and the X and the R qualifier? And I'm really only going to give it about, 1 minute, maybe 45 seconds. I'm going to go ahead and close this poll. It's going to close in 16 seconds. Great, so you can see those results now. So what I see is what I was hoping to see is that almost everyone marked C and E as the two that are true. B and E, or no, B and D, which I guess I should have put the letters up on the poll screen, were sort of my red herrings there, right? The validator does not reject data using the R. And the data usability team can, in fact, sometimes use that data even if it's qualified with an X. Now, the last one, all data can be used in some way. I guess that depends on how you want to think about your data. There is some data that we mark R. This data can't be used. But maybe there are still lessons we can take out of that data. Why did the laboratory not spike that LCS compound? Was it just a mistake? Was there something missing from the QAP? Is that not their normal process and you've asked them to do something different? So maybe there's a lesson learned you can take from that. So I want us to think about that as well. So to wrap up, I'll point out a couple upcoming events. We talked about the usability guidelines module, the usability guidelines coming out, the ICP-MS module. I do want to say we have a data validation webinar June 30th. You should be getting a save the date for that here very soon. And then we're planning a data usability webinar in August. And with that, I don't think I have time for questions, but you can certainly submit them and we will answer them either in the Q&A or via email or something later. So thank you.
Perfect. Thank you very much, Dr. McClellan. We appreciate your presentation. Next up, we have the discussion on the introduction to our incremental sampling portion of the meeting. Our first speaker today is going to be Dr. Ed Corral, and he is the Deputy Director of LQAO. So with that, Ed, would you like to go ahead and take it away?
Yes, thank you, Matt. And good afternoon, good morning, wherever you are. And welcome to this session on incremental sampling. As Jordan had mentioned earlier, the ITRC guidance for incremental sampling has been updated. Fortunately, we have 3 of my fellow co-authors from that document has agreed to come in and help the EMDQ, the EDQW, with an update of that document. I figured I would start off with just sort of an overview of what we're going to be going through today. So those 3 co-authors are going to be giving us, I guess, sort of a 30,000-foot view of the ITRC document, including why use incremental sampling, including the nature of soil sampling, some of the statistical concepts and applications, planning and cost. We did a lot more work relative to this part of incremental sampling with the update. And then how to actually perform the incremental sampling, including the ever important DQO development, right, through systematic planning and decision unit design. The field implementation, sample collection and the preparation portion, and also the ever important sample processing and analysis as well. And then finally, a review of the data quality evaluation and risk assessment. After that, I will then give the group sort of a brief EDQW's perspective of incremental sampling as well, and then we'll migrate directly into the open forum. So as I just mentioned, the ITRC document, or now ISM2, was updated in October of last year, and it was done as a clarification of some of the unclear or inconsistent information from the previous document that was published in 2012. And Mark Bruce and I were both on that initial team, and Mark, I can't believe that's been almost 10 years, but at any rate. So that document was also, the newest document reflects some advancements, so some things have changed during that time. We've updated some of the case studies and also some of the tools that are available as well, in addition to the update on the applications, the benefits, and also the challenges of incremental sampling. So the ITRC document contains 9 sections. I'm not going to read every single one of these, but there's 9 sections in all with an appendix with the updated case studies, as well as a tool with some statistical simulations as well that are available. The new guide really did expand upon, we spent quite a bit of time expanding upon systematic planning, risk assessment, and also cost considerations relative to the ISM1 document. There's currently training that the team put together. There's a 2-part training. There's 2 videos that are available. They are available as 6 modules. Those videos are available in ClueIn, and I left that link for you there below. And as I mentioned before, there's some new tools. We have a UCL calculator that you can find on the RTR website, ITRC website, which is a nifty little tool, and also the updated case studies are there as well. The ISM1 training and that guidance document still does exist. The ISM1 document goes quite a bit into the theories of incremental sampling. And if you're interested in seeing those, I certainly recommend it. So our speakers this afternoon, and I really want, again, to thank these three speakers for helping us out and giving us this overview of the ITRC document. They are going to be triple teaming this effort. The first speaker is my good friend, Dr. Mark Bruce. Mark's a corporate technical director for Eurofins Environment Testing America. He has experience in environmental monitoring, including sample preparation and analysis since 1979. He has participated in the development of several EPA methods and has worked in conjunction with the Army Corps in investigating developing tools specific to incremental sampling processing. He has been active on both the ITRC and Regulatory Council ISM teams, both in 2012 and with this update, like myself. Ms. Michelle Zeich has worked for the environmental consulting industry in Southern California since 1992. She is currently with Wood Environment and Infrastructure Solutions, or Wood in San Diego, California, as an associate project manager, managing and providing technical oversight for environmental restoration projects in California, Arizona. She has directed investigations at former range sites, industrial and manufacturing facilities, former aerospace testing facilities, Superfund sites, and brownfields for both Department of Defense and private sector companies and real estate developers. Ms. Zeich has been working with the ITRC on the incremental sampling methodology since 2018 and has executed several ISM sampling designs at former range sites and facilities with historical use of arsenic-based herbicides. Michelle earned a bachelor's degree in geology from the California State Polytechnical University of Pomona in 1992 and is a registered professional geologist in the state of California. Haley Brittingham is an environmental statistician with Neptune and Company Incorporated in Denver, Colorado, and has worked for the company since 2017. She's experienced in both fundamental statistical principles and their practical implications, and has contributed to the ITRC incremental sampling team since the onset in 2018 when we developed the team. So she designs and reviews sampling plans using a variety of sampling techniques, including both discrete and incremental sampling. She earned a Master's of Science in Applied Statistics from Pennsylvania State University in 2017 and a Bachelor of Science in Ecology and Evolution from the University of Pittsburgh in 2016. So with that, I'm going to turn this over to Dr. Mark Bruce, who's going to lead us through the ITRC document.
Thank you very much, Ed. And thank you to my co-presenters. I give you a little bit of an overview as to where we're headed. I'm going to be talking a little bit about regulatory acceptance and then touch on the two big questions of why use ISM and how to do it once you've decided that you're going to do it. So I'll be talking about the nature of soil sampling, and then I will hand off to Haley, who will talk about statistical concepts and planning, who will then hand off to Michelle to talk about cost analysis, systematic planning, field implementation, who will then hand back to me to talk about sample processing. And then I will hand off to Haley to finish us up with data quality evaluation. So ISM is about managing uncertainty, and it's designed to reduce the uncertainty in the knowable unknowns. Now, a knowable unknown is, let's say, for example, on a PCB contaminated site, is the PCB concentration in a particular part of the site. So if we looked in the right place with the right kind of tools and techniques, we would find it. So that is currently unknown because we don't have data on that, but it could be known if we look in the right manner. Now, ISM is representative by design. So what that means is that with the right methodology to provide representative site information that we can use it to inform environmental characterization and cleanup decisions, and that we're primarily focused on the average concentration of the contaminants of interest in a very carefully defined portion or area or volume of the site, and we do that by managing heterogeneity. From a regulatory perspective, the ISM2 team did a survey 2 years ago at this point, and at that point 84% of the states were reporting some use of ISM, and about 8 of them actually had ISM specific guidance that was available for the use of ISM within their particular state. From a participation perspective, Ed mentioned that back in 2012, the ISM-1 guidance was made available, and we did many, many iterations of live and recorded training. And in that last 9 years, that have been about 50,000 participants have participated in either the ISM-1 or the ISM-2 training. Now, the Interstate Technology and Regulatory Council produced the first guidance that was released in 2012, and then the updated one was released in October of 2020. And that team was led by a couple of really great state regulators from Tennessee and New York. They had recruited participants from federal, state, community, academic, and industrial representatives. So the first question that we want to tackle is, well, why use ISM? And as a part of that, we're going to talk about the nature of soil sampling, the statistical concepts associated with this, how to do the planning, and also take a look at the cost analysis. So in terms of the nature of soil sampling, I want to introduce 4 terms here and define them, what we mean in this context. So heterogeneity is variability in concentration at various spatial scales. We'll talk a little bit more detailed about that very soon. Representativeness is the concentration at the scale of interest. The signal is the spatial variability of that concentration that we're going to use to drive our environmental decisions. And noise is smaller scale variability that actually could potentially hinder those decisions by adding variability that gets in the way. So let's take a look at this slide here. So we've got heterogeneity at all spatial scales. In the upper left-hand corner, we've got heterogeneity at the landscape scale, which is usually what we do want to characterize because we don't want an average concentration for a many square mile landscape. On the other hand, in the lower right-hand corner, we have heterogeneity at the microscopic scale. We really don't want the concentration for the contaminant of interest for every individual particle within that particular site. So somewhere between the landscape scale and the microscopic scale, we've got a dividing line, and we call that the scale of decision. So if we look at the picture in the lower left-hand corner, this is some data from the state of Hawaii at a PCB contaminated site. And we can see that within just a 3-foot square, we have results that vary from 4.9 parts per million all the way up to almost 2,500 parts per million, all within a 3-foot square. The chances are we really don't want that much resolution, and that actually constitutes noise. So the question is, well, how do we manage this level of heterogeneity? Because we really aren't going to be making decisions at the 1, 2, or 3-foot scale. So that pushes us off to the upper right-hand corner, where what we call decision units. And these are sized with the appropriate resolution at which we actually want to make decisions. And ISM provides average concentrations for each of those decision units so that we actually have information that manages heterogeneity below the scale of decision but provides it at and above the scale of decision. So 2 key terms: the decision unit, it's that smallest volume of soil that we want to make a decision about, and we want to get that average concentration. That is the signal that we're looking for. An increment is just a small part of that decision unit, and we take a whole bunch of increments and combine them to form a sample, which then represents the entire decision unit. So the individual concentrations of those increments is actually the noise that we are trying to manage. So let's take a look at an example here. So here we've got some lead data that came from Dina Crumbling and in a paper that she had helped publish. The blue dots represent lead at less than 100 parts per million. The red dots are greater than 10,000 parts per million, and the other colors are concentrations in between. And you can see that we have very large differences even within an inch, because this whole square is only 16 inches. So we have both microscale and small scale heterogeneity that we really need to be intentional about managing that. Now you might say, well, a lot of our environmental contaminants are released as liquids, so they should be much more homogeneously distributed. But unfortunately, the landscape to which those liquids were released isn't necessarily flat. So we can very easily end up with small scale heterogeneity, even when things are released as liquids. And you can see, looking at the yellow and the red dots, which are spatially very close to each other, could produce very different results. And this would be true for PCBs, petroleum hydrocarbons, wood preservatives, such as pentachlorophenol. So as a simple example, well, let's see here. Representation always relates to a specific question about what we're trying to characterize at a given level of confidence. But occasionally, or maybe frequently, a sample that is representative for one question might not be representative for a different question. So one simple example would be if we collect a sample for lead analysis, that is not likely to be representative if we're looking for volatile organic compounds. So to kind of wrap up this section, it's all about managing heterogeneity. We work on managing small-scale heterogeneity in the field by using many increments within a decision unit to provide good spatial coverage. At the laboratory, we manage microscale heterogeneity with a variety of sample processing techniques, which we'll talk about later on in this presentation, to produce more consistent subsamples that are representative of the field samples that were submitted. So with this, I will hand it off to Haley, and she will take us through some statistical concepts.
Thanks, Mark. So I'm going to start off by talking about the statistical features of incremental sampling, including the averaging process and how that allows us to achieve better precision as well as normality. And I'm also going to discuss upper confidence limits, including what they actually are and how to decide if your project requires one. So as Mark explained, due to the heterogeneity of soil, discrete samples may be highly variable due to the potential for anomalies at different scales. So the image on the left shows the variation in concentrations that we might expect if we collected discrete samples. ISM designs combine material from across the decision unit into a single sample, so the sample result is an estimate of the average concentration of the decision unit. And the way I like to think of it is the sampling process actually does the averaging for us. So on the right, you can hopefully get a feel for that physical averaging process that we have in incremental sampling designs. So each of those three different colors represents a single incremental sample. And in this example, we're taking 3 replicate ISM samples. And for the ISM design, we've got better spatial coverage and many more locations and just more information that go into a single sample. So an ISM sample is also going to include a much larger volume of soil than a discrete sample. And that's why a single ISM sample is typically going to be much more valuable than a single discrete sample. And since ISM samples represent an estimate of the average concentration, statistics tells us that we expect them to follow a normal distribution, which is going to be more symmetric, and that's going to be helpful when we get to the statistical analysis. So as an example, the pink curve in this figure shows a hypothetical underlying distribution of the increments, and that's also the distribution we'd expect if we collected discrete samples. And when you collect ISM samples, you end up with a distribution like the blue curve, which represents the distribution of the mean. And for ISM, when we increase the number of increments and the size of our incremental sample, the distribution of the sample results becomes closer and closer to a normal distribution, and the individual sample results become more and more precise. So next, I want to talk a little bit about upper confidence limits. As some of you probably already know, a UCL quantifies the uncertainty around the estimate of the mean, and it's commonly used to be protective of human health and the environment against the risk of underestimating the average concentration. A 95% UCL means there's a 5% chance that the UCL is actually less than the true mean. So how do you decide whether you actually need to calculate a UCL? That decision really depends on your project objectives and the level of confidence that you need in your decision. Also, some regulatory agencies require practitioners to quantify the risk of an underestimation error, and the easiest way to do that is probably going to be to calculate an upper confidence limit. The most common upper confidence limits for ISM data are going to be the Chebyshev UCL and the Students T UCL. The Students T UCL uses the assumption of normality to calculate a UCL, and it's the most reliable choice for normally distributed data. The Chebyshev UCL is a non-parametric approach, so the data do not need to follow a normal distribution. And ITRC guidelines recommend using the Chebyshev UCL if your data are highly skewed. Because using a TUCL with highly skewed data actually has the tendency to underestimate the mean. But remember that ISM data is expected to follow a normal distribution, as I mentioned earlier. So if there's a large difference in the magnitude of your ISM samples, which indicates that your data may not be normal, then that could be an indication that your study design didn't meet the level of precision that was identified in the project objectives. And I'll talk more about that throughout the presentation. The Chebyshev and the TUCLs are usually the only available UCLs for the small sample sizes that are going to be most typical in ISM designs. Now, if you collected more than 7 replicates for a decision unit, then you might have other options available to you, like bootstrap methods. So for example, the percentile bootstrap method and the other methods that are listed here. Since the sample size of ISM designs is usually going to be quite small, it's not usually going to be possible to really evaluate whether the data you collected are normal or not. So the ITRC ISM team put together this UCL calculator, which can help you decide which UCL is best for your project. And so the calculator comes in the form of an Excel spreadsheet, which is shown here just to give you an idea of what it looks like. And so the idea is you enter the sample results in the green cells on the left for each of your decision units. And the calculator is going to compute both the Chebyshev and the TUCL and give a recommendation on which is going to be more appropriate based on ITRC's guidelines. And those guidelines are based on simulation studies that were conducted by the ISM-1 and ISM-2 teams. And so this calculator can be a useful tool, but as always, you're going to want to consider other information you have available related to the site, like the conceptual site model and the expected variation. So next, I'm going to talk about planning for the use of ISM data. And there's 2 parts I want to go over when it comes to planning for ISM data collection. And the first is your project objectives. So far, we've discussed comparison to action levels, but I also want to go into the statistical and planning considerations for other applications like background comparisons and site characterization. And you might also have a more complex site where you could have multiple sampling units or very large sampling units, and that's also going to be helpful to consider during the planning phases. The second part I want to talk about are the additional questions to answer during these planning stages. So these are whether to collect replicates, deciding how many ISM samples you need, and deciding how many increments to collect for each ISM sample. Now, background comparisons are a common objective for risk assessment that ISM sampling can be used to support. ISM-2 recommends using valid statistical tests for background comparisons. So for example, using a 2-sample t-test or ANOVA if you want to compare more than one area to background concentrations. Point comparisons, like using background threshold values, are not recommended due to their lack of statistical power. And so when you do background comparisons, there are a few things you want to consider. First, both the site and background data sets should be collected using incremental sampling. In other words, it's not recommended to combine ISM site data with discrete background data or vice versa. Also, the volume of soil per increment and the number of increments per replicate should be equivalent between the 2 designs. And finally, if you really want to maximize the statistical power of your background comparisons, then the number of replicates between the designs should be similar. It's a common misconception that ISM is not useful for spatial analysis. If you have adequate prior knowledge of the site and proper planning, ISM can be used to support a spatial analysis. So for example, for nature and extent. In this example, we have an industrial facility with a wastewater outfall area, which is outlined in red. And one of our project objectives is to determine whether contamination extends beyond that area. So in this case, 4 additional sampling units have been designated around the perimeter of the supposed source area. And so those sample results are going to retain those spatial relationships, and decisions could be made specific to those individual sampling units. Note that in order to design the sampling plan in this way, some prior knowledge about the site is going to be required. And so that's one possible limitation of using ISM for nature and extent. Also note that if the project objective includes defining spatial relationships on a small scale or with a very fine resolution, it may or may not be cost effective to use ISM. And so that's one of the components to consider during the planning phases. Now that we've talked about the project objectives and study questions, and maybe you've decided to use ISM for your site, let's talk about the questions you should answer during the planning process. The first is whether to collect field replicates. Depending on the project and the level of confidence you want, you might collect a single ISM sample in a decision unit, and that could meet your project objectives because of the increased precision that we achieve with ISM. That single ISM result could be directly compared to an action level to make a decision about the site. When you decide whether to collect replicates in a decision unit, you should consider the precision you want to achieve and how you're going to evaluate it. So with a single ISM result, it's not actually going to be possible to evaluate the precision and actually check whether the precision was met. And of course, keep in mind that 95% confidence is a common requirement for environmental projects because it allows us to quantify the likelihood of potential decision errors. So if 95% confidence is an objective for your project, you'll need to collect at least triplicates or at least 3 ISM samples. The next question is how many ISM samples you need to collect. Now, depending on your project, this question might relate to how many field replicates you need, but it could go beyond that as well. So for example, you might divide your area into many possible sampling units, and you need to determine how many units to actually sample from. So this decision requires many different considerations, including the variation in concentrations that's expected according to the conceptual site model. You'll also want to consider the magnitude of concentrations relative to the action level, or if you're doing background comparisons, the expected difference between background and site concentrations. And then finally, what level of confidence you actually need in the data. So these aspects could be considered qualitatively using professional judgment to determine the appropriate sample size. But if you have estimates available for each, then they could be considered quantitatively using a power analysis. And typically a pilot study is usually going to be necessary to get those estimates for a power analysis. And the last question I want to talk about related to planning is how many increments you need to collect for each ISM sample. And that's usually going to be between 30 and 100, but it does require some level of professional judgment. So the factors you want to consider are the size of your sampling unit. So for example, if your sampling unit is very large, you're probably going to want to collect more increments so that they can be closer together. You're also going to want to consider the expected scale of heterogeneity, or that noise that you want to average over. So capturing that heterogeneity within the ISM sample means you're going to get better precision between ISM samples. And then finally, in the event that the precision achieved doesn't meet the project objectives, you're going to want to consider the cost of the second mobilization, both in terms of financial and schedule constraints. And so with that, I'll pass it to Michelle, who's going to discuss a cost analysis.
Michelle, you might be on mute.
Hello? Can you hear me now?
Yes, we can hear you now.
Okay. All right. I apologize for that. All right. Well, thank you, Haley. So how much does ISM cost over more traditional sample methods? You know, very often, many of our site assessments are driven by available funding or how fast you can get the sampling and the analysis done. Less frequently, we think about the cost of the decision error or the cost of the environment if our data set isn't accurate. And while there's no simple and direct way to compare costs of executing a project using ISM over a more traditional sampling approach, within the ISM guidance itself, we wanted to provide some level of at least description about 4 general areas that you want to consider. And that is, you know, the financial costs, the schedule costs, or the change in schedule, any decision error, and environmental impact. And when you're talking, kind of another way to think about it is how much is the lawsuit going to cost you down the road if proper decisions aren't made? With that, okay, monetary costs are what we initially think of when we consider how much something is going to cost us. And if you break down a typical site assessment, there are monetary costs associated with planning, with sample plan review, field sampling, laboratory analysis, and data evaluation. Now, the most significant differences that we'll see with ISM affect your field sampling and your laboratory analysis. And we're going to take a little deeper look at that shortly. But first, I wanted to talk about, you know, impact to schedule. Probably one of the biggest savings that you can get with incremental sampling is that the sampling can be more complete. You're going to cover a larger area, and it's going to eliminate the need to go back and collect additional samples or do a data gap assessment. And so while it may take a little longer in the field to get that original data set, you're going to eliminate the second and third mobilizations that might be required with more of a discrete sample method. And then there's the cost of decision error. So often, you know, bad data, in essence, can equal bad decisions, which can cost money and also include a certain level of risk to your assessment. And the environmental costs, you know, what would be the risk of an incomplete assessment on human health for the environment? And those are some things that you need to think about more than just what is it going to cost me financially. But coming back to the financial aspects, what we did here in ISM2 is develop a number of sampling plans using both ISM and discrete sample methods. We wanted to compare a site using both ISM, the same site meeting the same data quality objectives, and what if we did during, what are the costs associated with discrete sampling? And so we wanted to, so we did that, and we'll present that cost comparison here. And then we also created a usable calculator for users to come in and generate their own ballpark estimate for a sample scenario that they may be considering. So that there, and here's the link to that. It's an Excel table that you can pop out and actually populate the cells yourself. All right, here's a cost
example scenario that I'd like to present to you. It was for a small arms range, and here's 2 sketches of both the selection of discrete samples and ISM samples. Now, obviously, this is up to your sampling team as you put together, so it's professional judgment. But if you're looking at a certain large area to adequately delineate or to assess if there is contamination on a site, you're going to probably want to spread out a number of discrete samples over the range floor and side berms, firing line, and the target berm. Now, if you look at this with an ISM perspective, you're going to separate these areas up into different SUs, different sampling units. And you're going to have one investigative sample with replicates for your range floor, one for each of the side berms, target berms, etc. So let's take these estimates and pop them into our cost calculator. Using the big difference, as you can see, that drives this is that you have ISM samples, a significantly less number of number of samples, 15 samples versus 132. Now, then there's the time associated with collecting those samples. And you may say, hey, wait a minute, how can it be just an hour to collect? One thing to realize is when you do collect ISM samples, you don't need to decon while you're with your sampling device within a specific decision unit. You are going to containerize that all into one container so that your labeling and your processing afterwards is reduced. And so just in general senses, you could have 30 increments, and with the right tools, you can collect those samples, depending upon the size of your area, in about 30 minutes. And that is just something you can think about as you're doing, what is the time associated with sampling at these sites? And there is in the training, the ICRC training modules, there is videos of people actually doing this sampling, and so you can get a sense for how long it actually takes. And so if you consider all of that, you're looking at a great reduction of cost. This is just for the number of samples and the labor associated with collection. Let's also consider laboratory costs. Okay, with laboratory, ISM does require additional processing on the laboratory, and laboratories are going to charge for that. So that needs to be weighed into your consideration. So your analytical per sample will go up. However, you're dealing with a significant reduction of samples. And so at the end of the day, we're looking at a case study somewhat similar to, anywhere from 12 to 13,000 to 84 if you use discrete methods. So take a look at this. Now, this is one example. We tend to see as you do these analysis, if you're looking at very small number of samples, it may not be cost efficient to use ISM. Definitely as the sites get larger, it's something that you're going to see a more significant difference. So please don't let cost be an issue here, because you really need to run through and look at what those costs are actually going to be before you make that decision. All right, you can pause right here for a little quick breather. Hopefully now you have a better understanding of why you should consider using ISM. And next we want to kind of talk about how do you do ISM. Okay, ISM is executed by completing 4 basic steps. And this is very consistent with any site assessment process. You're going to include systematic planning, decision unit design, field implementation, sample collection and preparation, sample processing and analysis, and your data quality evaluation and risk assessment. Now, the method to set up a systematic plan is very analogous to the data quality objective processes used under CERCLA. It's your DQO process. You start with a problem formulation. You're going to identify your study questions, identify any information inputs that you have, things that are part of your site conceptual model. You're going to define your spatial and your temporal study boundaries. And this last element there is directly related to defining your decision units and your sampling units for the execution of ISM. Now, I know the other two speakers have both talked about decision units, but this is an important element of the ISM design. DUs are basically that spatial study boundaries in which an average soil concentration is needed. It is the smallest volume of soil for which a decision will be made. And there are three general types of decision units. There are source area decision units, exposure area, and nature and extent. And then on the other hand, there's what you'll come across in the terminology as a sampling unit. And a sampling unit also represents an area for which an average soil concentration is needed. And it's any defined volume that is going to be represented by a single sample. Now that's very similar to a DU. However, in this case, they're not necessarily, the data that's going to be derived from these isn't necessarily going to be used in a decision process. DSUs can more appropriately determine an estimate for a certain area. It can help define smaller areas within a DU to make decisions. And I'm going to give you a couple of examples here momentarily to help understand this. Now, you saw this particular diagram from Haley's talk. Similar idea. We have a large DU, and within that DU, we have a number of sampling units. Now, our sampling units are targeting specific areas where it's how much soil concentrations are here in this particular area at the outfall, and then maybe which direction that might go. And so having this individual sampling units helps define this area. Now, ultimately, on the large scale, we're looking to assess the entire area of stress vegetation to see if those concentrations exceed a regulatory screening level. So that's when we're looking at the larger DU. Another example would be an exposure area DU. Think about it here. Where you have the entire property, residential property, is considered the DU. And we want it, that is because we're going to evaluate if there's a risk to those particular residents that might live on this property. Now, each EUs are broken up within this larger DU because you might want to consider, okay, we know that there are small children in this house that like to play in the backyard. We want to evaluate what their exposure risk, and that's a little bit different. So we want to take another data set here within this EU and evaluate that versus the exposure, again, to a child that may live at this house, et cetera. So just to kind of know, you can use these interchangeably, and it's up to you as the sample designer to determine how best to label to get your point across and communicate the goals of your assessment. Now, here's an example of a nature and extent DU. It's an excavation, and here we want to decide which samples, if we need to go extend that excavation deeper through your bottom DU or to any certain direction based on the sidewalls. And lastly, use another example of a nature and extent DU, but looked at as kind of on the vertical plane. You can use ISM to determine, have your DU set up vertically from a certain set of soil parameters or certain depth. And so it can also be used in that manner too, as well. All right, well then that gets us into planning for your field implementation. You're going to need field personnel that are properly trained in the collection of the collection procedures. It is a little different than going out and just grabbing a single discrete sample. You need to understand the site conditions, surface features, and the soil characteristics, and to know what tools might be required. Like, how hard is that soil? Are there a lot of cobbles that you'll need to negotiate? Do you need certain tools, different buckets, things of that nature to put together your samples? You need to determine your increment size. Okay, you have, say, 30 to 100 increments. Now, how much soil are you going to need to run that complete ISM sample? This here is an example equation that can be used to evaluate that, but this is all in the ISM guidance itself. Now, you're going to want to also select your sample containers based on the preparation requirements that you need and the analysis. And then you need to do some special planning if you're dealing with subsurface investigations. Special equipment will be necessary to get samples at certain depths. All right, and then sample collection and preparation includes locating your DUs and the general area of your increments. You want to identify the travel path so that you most efficiently can get through your sampling DU and be consistent with your approach. Another benefit to ISM is that your data is representing your entire decision unit. So your survey data really only needs to identify the size and location of your DU. You don't need to survey all the individual increment locations for that reason. Now, there are different tools that you can use. This is actually a photo of an incremental sample, and the key item here is that you want to be consistent with your mass of collection for each increment. So the sample tool can help you with that. You also want to make sure that you collect samples throughout the entire depth of your DU. In many cases, surface samples require collection from 0 to 6 inches. Make sure that your sampler will cover that depth when you do collection. Now, all of this planning helps the execution of the sampling be effective and very efficient. And that's something you want to strive for because you are collecting quite a few increments. Other things to consider, sampling for VOC analysis. In the field, you'll need to containerize that, typically in a pre-preserved bottle or jar, and you'll pull in the smaller increments there. In the case of doing subsurface samples at a certain depth, you might need to split your core to reduce the amount of mass that is going in to be submitted to the laboratory. And also, like we touched before, decontamination only needs to occur on the DU level or the SU level. So in all the individual increments, because it's part of the same sample, it won't require as rigorous of a decon procedure. And so with that, I'm going to pass back to Mark to talk a little bit about the laboratory processing.
Thank you, Michelle. So as you can see, it takes a lot of planning and a lot of effort in the field to produce representative samples, and we want to continue that level of effort at the laboratory, where we want to make sure that we do the right kind of processing to meet the data quality objectives for a particular project. So we're going to be talking about the multiple sample processing options and some of the combinations, and we want to select those based on site characterization objectives. So we've got 6 areas that we're going to touch on: soil moisture management, disaggregation, particle size selection, particle size reduction, subsampling, and then effects on digestion and extraction. So the first is sample conditioning, and most of the time what this means is that we're going to do air drying at room temperature, and perhaps in a simple case, spread it out on a pan, put it in a ventilation hood. And the goal here is simply to produce dry crushable soil clumps, because dry samples that can be have the particles crushed are much easier and less expensive to work with. Now, more recently, a number of laboratories have produced what they call air drying towers, and that's shown on the right-hand side of this particular slide. And you can see many racks of samples. The door that is open, you can see has filters built into it. And what you can't see on the back are fans, and it basically pulls filtered air across the surface of each soil sample to dry it uniformly without risking cross-contamination from one sample to the next. Now, after we have our dry, crushable soil clumps, we need to break them up so they're ready for further processing. And that could be done with a hand mortar and pestle, where we just gently crush up the dirt clods, but intentionally don't hit things too hard because we're not trying to do milling. So we want to leave those hard crystalline particles intact. Another way to do disaggregation is to put the sample in a bladed coffee chopper. That blade spins around and busts up the dirt clods. Another option is what we call the rotary hammer disaggregator, shown on the far right-hand side here. Now, after we've broken up the soil clumps, when it's appropriate, we will run through particle size selection using sieving. And one common example of that is to use a number 10 sieve to remove all particles that are greater than 2 millimeters in size. And that produces what is sometimes referred to as operationally defined soil. There are other types of sieves, other sieve sizes that can be used for other project objectives. There are some projects that it's not appropriate to do particle size selection at all. The next option is particle size reduction via milling. And the two most common milling options are the puck mill and the ball mill. In this case, regardless of which option, the goal is complete particle size reduction. So we're going to turn everything into a flour-like particle. So the puck mill has been demonstrated for energetics in EPA method 8330B and some short list metals projects. And the precision improvement is pretty significant, leading to smaller RSDs, et cetera, which can help with managing that microscale heterogeneity. The ball mill, it's less expensive, a little bit less rigorous, but it's still suitable for many applications, and it gives us a moderate improvement in precision. So when we're choosing the milling equipment, we want to consider, well, what analytes are we talking about? What are their concentrations of interest? What are the mill materials that are being used, because it is an abrasive process. So some of the mill materials do end up in the sample. And then what is the final particle size that we need? Now, after we've gone through whatever processing options are appropriate for a particular project, the laboratory needs to produce an analytical subsample to run through the digestion or the extraction process. And by far the most common option is what's called the two-dimensional slab cake. And this produces acceptable representativeness at reasonable cost. So it's kind of a miniaturized version of what's done in the field. We spread the sample out in a pan, divide it up into a grid network, and then using a scoop that's blunt end and has sides so that we can more or less equally represent the top, the middle, and the bottom of the slab cake, we collect increments from each of the different grid cells, combine those to produce one analytical subsample. And then if we need to do multiple subsamples for the same field sample, we basically smooth things out and start all over again, and we can produce as many analytical subsamples as are necessary. Then the last step before we actually head to the instrumental analysis is to do some sort of sample preparation. So that would be digestion for metals or some sort of organic extraction. And the statisticians over the years have determined that for most environmental methods, we would like to hit a minimum of a 10-gram subsample. Well, most of the organic extraction processes use 10 to 30 grams, so we're already at kind of that sweet spot. Unfortunately, many of the inorganic methods use smaller subsamples. So, for example, a typical metal subsample is in the half gram, 1 gram, maybe 2 gram range. Well, for labs that do a lot of ISM work, we have frequently gotten requests to do, okay, a 10-gram subsample for metals digestion. So labs that do a lot of these have actually scaled up their metals digestion so they can actually accommodate 10 grams of sample. So this is something for the project planners to keep in mind when you're doing that planning and have those initial discussions with the lab. Now, there are some less frequently requested inorganic methods, let's say for cyanide or something like that. And most labs haven't scaled those up, excuse me, to larger subsamples. And that's an important thing to talk about if those parameters are of interest. So with that, I will hand it back over to Haley to talk about data quality evaluation and risk assessment.
Thanks, Mark. So now I'm going to talk briefly about data quality evaluation and data verification, validation, and usability as they relate to incremental sampling. And I'm going to go over the practical implications for risk assessment, including what does that confidence interval or the level of precision actually tell you, and how you might use that to modify the study design if necessary. So most of you are already familiar with data verification for discrete sampling, and the process is going to be similar with incremental sampling. So of course, making sure that the data are complete and that the sampling plan has been properly designed and carried out. And for ISM, this means both ensuring that the correct number of replicates were collected and also that the correct number of increments were collected for each. And so next, data validation for incremental sampling is also similar to data validation for discrete sampling. So making sure that the standard operating procedures, for example, laboratory SOPs for ISM data were properly followed, and confirming that the correct qualifiers were assigned, like correctly identifying non-detects. And so for ISM, you might have special considerations when you do have non-detects, particularly since ISM designs usually have smaller sample sizes. And then also, of course, the evaluation of performance criteria. So for example, were any data rejected due to not meeting the quality control criteria? And then finally, data usability is a retrospective look at the project objectives and sampling design. And once again, it's also similar to evaluating data usability for discrete samples. And so the outputs from data verification and validation are used to evaluate performance criteria and the implications of unacceptable results. So for ISM, data usability, part of data usability is looking at the relative standard deviation, or the RSD, or the coefficient of variation, the CV, and making sure that those met the precision objectives that were laid out during the project planning process. And so the precision that's identified during the data usability assessment can help you decide next steps for your project. So for example, if your UCL is above the action level, you might conclude remediation is necessary, but that could be due to unacceptably high concentrations or unacceptable precision. And if it's due to unacceptable precision, then it might help to collect additional data. So examples where collecting more data might help are if the mean is below the action level, but the UCL is above, or if the mean is only slightly above the action level and the precision that was achieved was not as good as anticipated in terms of the relative standard deviation or the coefficient of variation. And then examples where it might not help to collect more data are if the mean is much greater than the action level and or the precision achieved was adequate and met the levels identified in the project objectives. So how should you actually modify your study design if you do decide to collect more data? The most common is going to be increasing the number of field replicates or ISM samples, or you could increase the number of increments for each ISM sample while also increasing the total mass of each sample. And less commonly, depending on the site and the study design, you could focus on trying to decrease variation by redesigning the placement of your sampling units in order to better characterize areas with elevated concentrations. And so the decreased variation also results in a narrower confidence interval width or better precision. And this might be an objective, particularly if your study area was very large. So for a large study area, low precision could be an indication that you actually have multiple distributions of concentrations within the area. And so breaking up the study area and redesigning the placement of your sampling units is going to better characterize areas with elevated concentrations and allow you to achieve better precision for each of those smaller areas. And so that concludes the content of our talk today. We talked about regulatory acceptance, which has been achieved in many different states. And we talked about why you should consider using ISM. Mark went over the nature of soil sampling and how ISM lets you use the scale of decision to drive choices. We went over the statistical concepts that lead to better precision in ISM and how you should use project objectives and the conceptual site model to drive your study design. And then finally, Michelle talked about the cost. ISM is not necessarily more expensive and may even save time or money in the long run. And in the second part, we talked about how to do ISM, including how to plan out your decision units, accounting for the objectives and conceptual site model. Michelle talked about how to prepare for the actual sample collection, and Mark talked about how effective sample processing manages microscale heterogeneity. And finally, we talked about data quality evaluation and how the precision that's achieved gives insights into next steps. And at this time, we'd be happy to take any questions.
Perfect. Thank you very much, Mark, Michelle, and Haley. We do have some questions that we're going to go ahead and field relating to the ISM discussion. We'll save some of the other questions on the other topics for the open forum. So to start off, we have a question here. Can you use data collected from discrete sampling for power analysis for ISM sampling?
Yeah, I can answer that. So the short answer is yes, you would be able to use that information with a word of caution. So the estimates for variation that are going to be needed for a power analysis are going to be different between ISM and discrete designs for the same data. So a trained statistician is actually going to be able to translate to give a rough estimate of the variation you would expect from an ISM design given discrete data. So it's not going to be exact, but it would give you a general idea of the estimate that you could use in a power analysis.
Perfect. Thank you very much for that response. We have a question. Can ISM be applied to soil vapor projects?
I'll tell you what, I'll take a stab at that one. The ITRC guidance, either the first version or the second version, doesn't actually address soil vapor projects. Certainly the principles could be applied, but we would have to adapt. I mean, the process of collecting soil gas is very much like that of collecting increments. We'd have to work on coming up with an appropriate laboratory process to actually combine those increments prior to the actual analysis step. I'd be willing to have that discussion and include some of our soil gas experts. But it hasn't been done yet, but that doesn't mean that it can't be done.
Thank you very much for that response, Mark. We have a question. Do you agree with the decision mechanism 1, which suggests a decision unit can reliably determine to be clean or dirty by collecting only one ISM sample and comparing the result with the project action limit using completely subjective criteria?
Yeah, this is Ed. I will venture into deep waters with answering that very loaded question. So in the end, I think the response to that is it really depends. It's up to the project team, right? I mean, I think that in the end, that really is the answer. But I think the question is voiced relative to the fact that, do we have enough statistical power to be able to make that decision with some confidence? So while I don't disagree with the question that typically we would need more information to be able to make that decision with some confidence, I would say that we should leave that up to the project team to ultimately make that decision.
Thank you, Ed. We have a question here. Why are such large samples required? Can I reduce the subsample size to make an ISM sample that can be processed as a unit, say 500 grams?
Okay. Sample size is driven by two considerations. One is how big does a sample need to be to actually represent the decision unit? So that's essentially the diameter and the length of each increment. So depending on how much volume you're trying to represent, I mean, if you're trying to represent a 2-foot interval, then you need 2-foot long increments or something representative of that. So that's the biggest thing that actually drives the size of the field sample. And then once the sample is back at the lab, in terms of actually going through all of the various processing options, at least those are determined to be appropriate, some of those processes actually work better when we have more sample mass to work with.
Thank you very much for that response.
Can I jump
yeah.
in and so this is Brian Jordan with the Army. So it's important to remember that you need to maintain that understanding of your DQO. So you would not want to subsample in the field that would violate that, what your objective was, which is to sample or provide a sample to the laboratory that represents the total decision unit. So if you do that subsampling prior to some of the other processing that's needed, you're gonna increase your fundamental error, and you're basically, you've nullified all the attempts that you made to represent the whole decision unit, and you've now reduced yourself to something that is not an ISM sample anymore. So you have to be careful that you understand the impacts of each processing step and how that impacts your error going forward.
All right, thank you. We have a question here. Can you expand upon the SU, EU, and DU definitions? It seems like you are making a decision for each EU, so wouldn't these be considered DUs?
I can answer that one. An EU is a specific type of DU that you're looking at exposure to a certain receptor. And not so that, don't get confused, and it's really more of the nomenclature that you use as the professional that's designing this thing. You can call everything on your site DUs if you so choose to. You can designate smaller areas SUs to emphasize, your general purpose. It's how you're going to communicate to your reviewers and to your sampling team the priority or what the reason is for sampling this particular area. So you can use these terms, they're very, very similar. They're just tools to be used to help communicate your ultimate objective for that particular area. Does that make sense? So.
Perfect. Thank you very much, Michelle, for that response. I believe it's the last question that I have on my priority list before we go to Ed's presentation. Regulators are requiring the multiplication of ISM results by the number of increments collected to determine if the screening level has been exceeded. How would you respond to regulators on this?
Yeah, this is Ed, and I had already answered this on the chat, by the way. But as all of you have probably heard this before, when it comes to composite samples, right? We've heard this many, many times before, and that statement is basically an assumption, and that assumption is that of all your increments, one increment contains all the mass of the contamination, and all the other increments are thereby diluting it. Right, that's the assumption you're making when you're asking to do that basic multiplication effort. So Haley could probably speak to this better than I can, but certainly you could say it is possible, but it certainly is not probable. So that's a very conservative assumption that you're making in doing that. And I think it's safe to say that typically that's not a calculation that we would think is going to be there's going to be a high probability for that situation to happen.
Yeah, thanks, Ed. I would just add that, you know, that is a conservative assumption. It's the most extreme assumption you could possibly make. So, you know, I would just consider in terms of your site and your conceptual site model, how the contamination is likely to be distributed and whether that's going to give you a reasonable decision or not. And I would say in most cases, probably not.
Perfect. Thank you all for those responses. With that, I'm going to pass it back to you, Dr. Corral, to kind of conclude our discussion on the ISM initiatives of the EDQW.
Okay, thanks, Matt, and thanks for the great questions. I was just going through here, and we're getting a whole lot of questions. I don't know if we'll be able to get to all of them, but before I move on, I really want to thank our previous speakers, Michelle, Haley, and Mark. You did a great job. I think it's safe to say that we could probably spend a week talking about incremental sampling and the ISM guide, and I don't think we'd get to all of it. So you guys did a really good job at that overview, and we appreciate your participation. So after that great review that we just received from our previous speakers, this slide might seem a little generic, but if you will indulge me, I hope to use this as sort of a demonstration of some of the data quality aspects of ISM that are really important to the EDQW. You know, I don't, if you're like me and you really like, I mean, I love peanut butter on bread or peanut butter on toast, and most normal people are going to take that peanut butter and they're going to spread it evenly, right? To obtain a reasonable average concentration of unit peanut butter per unit bread per bite, right? But you know, I can easily see someone like a young Sheldon say that if you're going to consume the entire piece of bread, then basically heterogeneity doesn't matter, right? Because in the end, you're going to consume a total mass of peanut butter per unit bread, and it's going to be the same no matter what. And in the course of chewing and digesting, and we're going to process everything. So that would be a very abnormal way of eating that piece of bread and peanut butter. I mean, it's the same thing as balling it up and putting it into a blender, right? And pureeing it and drinking it. It's the same thing. Now, that would be a very abnormal way of eating toast and peanut butter, but you can't argue with the logic, right? Young Sheldon is actually right. But young Sheldon, in this case, he's saying that he basically doesn't care about the spatial heterogeneity, and Mark talked about this, which is the small scale heterogeneity. And he also doesn't care if it's smooth or chunky or maybe even has large peanuts on it. That's the microscale, or what I call compositional heterogeneity. The true power of utilizing ISM, the ISM process, is that the nature of heterogeneity in the decision unit, in our case, our decision unit is the piece of bread, really is not important, right? Mark called it managing heterogeneity. I like to call it normalizing heterogeneity, but it's all basically the same approach. Now, you will hear many practitioners say that there are no such thing as hotspots. Well, that's really kind of silly, right? Because we saw a previous slide from Mark that showed that spilt milk, and releases in the environment rarely happen homogeneously, right? But what that practitioner is really trying to convey is that, number one, with our sites, typically when it comes to cleanup, we're looking at average exposures to a contaminant to human health in the environment. And that's typically what drives our cleanup, right, is the mean concentration. And the other aspect to that, of course, is that ISM basically doesn't care about heterogeneity. Now, you'll also hear probably that same practitioner say that ISM does not dilute hotspots or these areas of higher concentration. Now, I actually have a harder time with the statement because obviously, and you can look at any of these slides, for some of these sampling units, right, we're going to have increments, assuming we take increments throughout the piece of bread, we're going to have some increments that have no peanut butter, and we're going to have other increments that have a lot of peanut butter. And where I come from, that's called dilution, right? But I've learned over the years really not to pay much attention to that argument, because dilution in this context is not intended to have a negative connotation, right? It's just the price we pay to get that better mean estimate. So regardless, correctly obtaining a reasonably unbiased estimate of the mean is highly dependent upon the CSM, the nature of the characteristic of interest, and making sure that you perform everything correctly during that process. So more on that in just a second. Before I leave this slide, I did want to mention this. You know, if you think about it, all samples received by the laboratory, the results should be basically mean concentrations, right? They should be mean concentrations of what was in that sample container. If you process it, homogenize it, and process it, and subsample it appropriately, right? Mark showed us some slides on this earlier. We've heard the historical practice of a soil sample coming into the laboratory in a small scoop. I mean, Mark talked about for metals, you know, we usually digest 1 to maybe 2 grams at the most. And we take that small scoop and we analyze it, and there's no way that that's really going to represent what was in that sample container. And we've heard of this happening. But you know what? We have really demonized discrete samples because of that. And look, that's a manifestation of improper homogenization and subsampling. It is not exclusive to discrete samples. So discrete sampling really has been unfairly demonized on this point. And what really is important is that regardless of our sample, we have to make sure that we're using the appropriate processing, homogenization, and subsampling prior to doing our analysis, right? However, it certainly is absolutely true with discrete samples that assuming it has been homogenized and assuming it's been subsampled properly, certainly it only represents a concentration of a much smaller volume or mass of soil at our site relative to an incremental sampling, which has much higher coverage. All right, so incremental sampling, look, incremental sampling works. It's a great tool, but like all methods, it must be appropriate for our data needs. It needs to be cost effective, right? Michelle was talking about this. And then Haley was talking about the planning aspects. It has to be planned and it must be executed correctly. You can visualize from the previous slides that I had that obviously coverage is really critical for that spatial heterogeneity. And ISM generally is really good at this and typically requires about 30 to 50 or maybe even more increments. And you know, coverage is probably, in my opinion, one of the largest benefits really of using incremental sampling. But it's also important, and Haley talked about this, it's really important that all the increments have the same volume, right? And that they do not potentially bias the end result. You can certainly consider that in the previous slides where we had some of the chunks, right? I really like chunky peanut butter myself, but those chunks are part of the parameter of interest, so we can't exclude them. And the increments cannot exclude a parameter of interest, otherwise we're potentially biasing our sample. So once we sample that, assuming we've sampled those correctly, now we have to process them, right? Because that represents compositional, or what Mark called microscale heterogeneity. It's obviously important that this processing that we do doesn't degrade our characteristic of interest, resulting in a negative bias. So we know that many organic analytes are thermally labile or unstable, and therefore processing steps may need to be different for different analytes. It's really not a one-size-fits-all in terms of the methodology. We also know that, you know, like peanut butter, there are some analytes that are really good at being sort of sticky, right? They can absorb onto certain surfaces, and this can create a cross-contamination problem in the laboratory, resulting in a positive bias, right? So this suggests a need for processing, or what we call grinding blanks. And as all of you can imagine, this is greatly exacerbated when the project action limits for the analyte of interest are in a very low range, part per trillion or even lower. So positive bias is an absolute real issue, and it really can't be ignored. So, you know, again, the previous speakers, you know, talked about this and summarized it, but keep in mind that ISM is not just what's happening in the field. ISM is a process. ISM does provide, as I said before, great coverage, and compared with the coverage needed for discrete samples, right, ISM is usually going to be more economical, and Michelle talked about this. But the laboratory side of this ISM process is not necessarily trivial, and Mark talked about some of these aspects. We are bringing very large samples into our laboratories, And the processing, the drying, the sieving, the milling, the subsampling requires specialized considerations. Now, what we found is that many project teams are actually attempting to sort of avoid some of these issues associated with the processing by simply excluding it, right? They're doing the field component of it, but they're hoping that the compositional heterogeneity doesn't affect their results. Unfortunately, what's going to happen, and Haley was talking about this, is your replicate precision may greatly suffer because of this, and you're going to get excessive RSDs. So ignoring high RSDs defeats the purpose of wanting to use incremental sampling, quite frankly. We've seen high RSDs of 80, 100%. We've seen RSDs even higher than that. And obviously, when you get precision like that, it means that you are not getting representative results. And as Haley said, you're probably going to have to go back and resample. So finally, as I said before, the processing may not necessarily be universal, right? And therefore, the ISM processing has to be validated. Now, I want to remind everyone that the folks from the Army's Coal Region Lab, Dr. Jenkins and Dr. Clausen and others, these folks spent years understanding the behavior of explosive residues, the fibers, and the appropriate sample processing that's needed for explosives in method 8330B. And they did that with a very thorough validation. So what we are planning is the EDQW is planning sort of a validation guide for incremental sampling this year. And we hope that this guide will assist project teams and also laboratories and some of the appropriate considerations for incremental sampling validation for constituents other than explosives. All right, let's switch gears a little bit. For those of you who have attended the EMDQs, you've probably heard me speak on this item before about surrogates. Surrogates, as many of you already know, are sample-specific data quality indicators. Now, again, I want to emphasize these are sample-specific. They're not batch-specific. Surrogates should be added to every single sample. And they are a part of EPA organic methods to evaluate the effects of sample processing and analysis. Now, historically, that means we've typically added surrogates directly to our 20 or 30 grams of sample right in the toxin extractor, right? Well, keep in mind that if we're going to follow the true intent of what we're supposed to be getting out of surrogates for the EPA methods, those surrogates need to be added to as-received samples prior to processing. That means that we're adding surrogates not to 20 to 30 grams anymore. We're adding it to 1 to 3 kilograms of sample. In addition to that, you can't just have a stock solution of surrogates and inject 20 to 50 microliters into 3 kilograms of sample. You're not going to get good dispersion doing that. So what we think needs to happen is we need to have surrogates that are actually in a solid matrix. And of course, because you're adding them to much larger samples, they have to be at the right concentration. But the trick is these are not commercially available currently for any of the analytes. Now, there's a supply and demand aspect to this also, isn't there? We have wonderful organizations like ERA Waters that'll make these things for us, and they're very, very good at it. But of course, they are not going to make these things in bulk unless there's a high enough demand to do it. And who could blame them? Because that's a business decision. So what we did, the EDQW, we did what I call a proof of concept study, and we selected PAHs in soil. And the reason we did that is we went and did a data call for what is the one test that's highest in demand within the DoD in terms of incremental sampling other than explosives. And that was clearly PAHs in soil. So the objectives of this efficacy study were very, very simple. That is, we reached out and got the assistance of ERA, and we thank them for that, and some assistance from some of our accredited laboratories to look at some different fortified solid surrogates, what type of surrogates and what type of matrix can we use, and can we properly disperse that sample within a 1 kilogram sample prior to analysis. And what we found as part of that, as you can imagine, is number one, the dispersion was really, really good. Our precision was really, really good. But of course, bias was affected by the sample processing. So the output of this is we need to do some more study, right? We need a more thorough investigation. And that's exactly what we've planned for this year, and we're in the process of scoping a further validation study for that currently right now. So let's talk about the QSM. Some of you may be familiar with table B23 from the current version of our quality system manual. Now, this was our attempt, maybe you could call it our failed attempt, I don't know, to incorporate some of the same data quality aspects that are associated with ISM, some that I've already mentioned, right? It includes things like surrogate considerations need to be added early, grinding blanks, and the like. Unfortunately, the laboratories still can't do anything about this surrogate issue, right? And the project teams were not prepared for the additional costs associated with things like grinding blanks. So in fairness to our laboratories and for our project teams, the EDQW has not really enforced table B23, and we've taken the stance of allowing the projects to work with their project chemists to basically self-regulate their needs for ISM and data quality needs during QAP development. Now, the previously mentioned validation guide certainly we feel will help, and again, that should be out this year. And while we still believe that the quality requirements that are currently in table B23 has all the correct measures in it, we firmly believe that it's just not practicable at this time. And therefore, as Alyssa said earlier, it's going to be removed from version 6. Now, that does not mean that we may not add method-specific tables later. In other words, these won't be generic like table B23. They'll be more method-specific. And I assume if we finish this validation study for PAHs, I would assume PAHs would probably be the first method-specific table that we utilize. Whoops, sorry about that, I went the wrong way. So in summary, right, again, ISM is not just what happens in the field, it's a process. So the EDQW recognized that ISM is a good tool, okay, but it must be selected as appropriate for the objectives by the project team. Application of incremental sampling to constituents other than explosives in 8330B is going to require further validation to further evaluate the precision and bias concerns that I mentioned earlier. Again, it's a great tool, but it's not the only tool. Discrete sampling has been, in some cases, unfairly demonized in the past, but assuming proper homogenization and assuming proper subsampling, discrete samples do only represent a smaller volume of soil, and that's absolutely true relative to the coverage that you would get with incremental sampling. But the EDQW at this time, we support allowing our project teams the flexibility to use systematic planning to develop the appropriate sampling design, their appropriate tools, and the quality considerations that they need, right, for their particular objectives. Again, table B23 is going to be removed from QSM version 6, but we can't rule out the fact that we may add method or analyte-specific tables later. And finally, again, our data review and management subgroup is planning. We haven't really even outlined it yet, but we're planning a validation guide here in the very near future. And finally, you know, I'm not really big on adding cutesy slides to my presentations, but I thought hard about excluding this slide. But you know, it does allow me to conclude with sort of my opening theme about peanut butter, right? Plus, who doesn't love a puppy? So, so this is my dog on the left, taken about 3 years ago, and again, more currently on the right. And I can assure you that he does not care whatsoever about heterogeneity. So. I'd like to thank our previous speakers. I want to thank all of you for participating in this webinar, and I'm going to turn this back over to Matt for our open forum. And again, in the open forum, you can ask questions of anything that I presented, our previous speakers, or any material that has been part of this webinar.
Perfect. Thank you very much, Ed. And yeah, as Ed stated, the open forum is open for discussion on any of the topics that we went through today. And with that, we do have some leftover top questions regarding the ISM, so I would like to keep that ISM theme moving forward a little bit before we go back to some of the questions on the previous presentations. So starting off with the first question, is ISM used primarily on sites with surface or more shallow subsurface contamination?
Yeah, this is Ed. I can take a swing at it, and certainly I invite any of our previous speakers to add on. Certainly, incremental sampling is a lot easier for surface and slightly shallow subsurface samples. As you can imagine, as I expressed earlier, you have to make sure that you're not creating a bias when you select those increments. So the deeper you go, the harder it's going to get a core that's completely the same for each and every increment. And the other challenge is that as you start taking deeper and deeper cores, the soil tends to compress, and now you're in danger of now not taking the same volume, the same mass with each and every sample. So it can be done at deeper depths, but it's a little bit more challenging.
Yeah, I'll second that comment by Eric. It can be done, but it's a lot more complicated. If you're doing subsurface samples, you're looking at using a direct push rig to put in as many as 30 or more sample locations and then collecting those steps. So it does add a level of complexity. It's very doable, but it's not as often practiced because it is a little bit more complex.
Thank you for you guys' response. We have a question. The presentation noted VOC samples, but ISM does not seem to indicate sampling for VOCs. What are the options for sampling VOCs with ISM?
Okay. For volatiles, obviously, we need to avoid the common first step of air drying. And that's where, and Michelle touched on this a little bit at the end of her section. If you're going to collect ISM samples for volatiles, what we typically use is the large-scale methanol preservation option of EPA method 5035. And so rather than 1 5-gram plug going into 5 milliliters of methanol, we typically scale that up so that we can put all of the increments into one large methanol preserved bottle. That's the most common when ground shipping is an option. If we need to do air shipping, then we need to get under the 30 milliliter DOT limit. So we break that up into multiple medium-sized bottles. But using a methanol preserved option, we can do ISM for volatiles.
Thank you very much for that response. We have a question here relating to the validation of ISM data. Any lab failures that leads to data uncertainty or worse, rejection of the data has a much bigger impact on 3 ISM replicates as opposed to 30 discrete samples. Are there any ways to work around these difficulties?
Yeah, that's a good point.
Go ahead. Go ahead, Michelle. Go ahead, Michelle.
This is Haley. I was just going to say that's a good point with regard to if you do have fewer incremental samples compared to a discrete design, then 1 out of the 3 being rejected does have an impact on your data quality. As far as getting around that, I would just say, to consider that possibility when you're doing the planning process, and possibly consider increasing the number of replicates depending on, I guess, what's at stake for the project and the implications of a second mobilization.
Yeah, thanks, Haley. This is Ed. And, the only thing that I would add on to that is, if you think about it, I had expressed in my last couple of slides how important, how vitally it is important that we do all aspects of the process correctly. And one of the reasons is because if you think about it, if something goes wrong, now you have a much larger area that's not representative. I mean, you think about it, right? If you have a failure for a decision unit that's 1 acre relative to 1 discrete sample, you sort of have higher to fall, right, with these things. So that's why it's so incredibly important that you plan and execute incremental sampling properly.
Perfect. Thank you guys for your response. We have a question here.
Can I wait before you go to the next one? Can I just jump on to Ed's statement there? I think it's important that you also evaluate if you're going to be making very important decisions with your ISM. that you do a pilot, that you go out there and make sure that the laboratory and the field samplers and all that understand the processes and go through that data set. If you have that possibility to do that pilot and evaluate your data and then say, okay, now let's go take the next 100 ISM samples. So go do 10 of them before you do your 150 samples. So you understand all your processes very well prior to the major commitment of your full scale exercise.
Thank you, Brian, for that addition. We have a question here. If the DU is the smallest soil volume for which a decision will be made, can different decisions be made for different SUs? If not, how are the sampling unit utilized in the remediation decision?
I can answer that one. And a DU typically will have, you're going to want to have to determine your reproducibility. So in some ways, you could say a DU is going to have your adequate replicates, whereas since you are doing an say you pick an SU for another purpose, maybe you don't need that level of precision or reproducibility for that particular area, or you don't need to document it. So that's when you may want to use, an SU there. That doesn't necessarily mean that you can't or you shouldn't use replicates on an SU. Again, it all has to do with, this is the nomenclature to help explain and guide your data quality or your data, the ability for you to collect your data and to understand how you're going to use your data. So don't be wed so much to, an SU versus a DU. It's all in the focus of what you're going to do with that data from that particular area at the end of your assessment.
Thank you very much for your response, Michelle. We have a question. If you can take sections of a core as an increment rather than the whole core, can you also homogenize your core in the field and submit a portion of the mass as the increment?
It is really difficult to truly homogenize just by mixing, which is why we have all of the different processing options that we use at the lab. Sometimes mixing actually makes the heterogeneity worse by causing stratification. So if the core is too big to be practical as an increment, there are other mass reduction techniques. Michelle had a picture of one of them called the core slice, where you essentially take a representative portion down the edge of the core. And that tends to be much more representative than what you can achieve by trying to mix and then subsample in the field.
Thank you, Mark. We got a question. Does analytical hold time start upon completion of the ISM process or at the pull of the first sample?
ISM sample collection and processing does not change hold times. So when you start collecting in the field, the hold time clock starts running, just like it does for discrete samples.
Agreed. Thanks, Mark.
Thank you for the response. How do we deal with foreign matter in sample aliquots?
That's largely going to depend on what your project objectives are. I mean, if you've defined foreign matter as, grass, big stones, sticks, leaves, then it's appropriate to remove them, just like is done for discrete samples. And if you've specified some sort of sieving, then oftentimes that can be very effective at removing larger particles. Now, if you've got some other type of foreign matter that isn't different in size, then we might need to use different techniques for separating that.
Thank you, Mark. Is it appropriate for the laboratory to process ISM samples without drying?
There are some instances where that is actually the best option. There are some of the lower boiling semi-volatile contaminants of concern that potentially can be lost during an air drying step if they're not strongly bound to the soil particles. Think fresh diesel fuel spill on sand. So certainly there would be the possibility that you might lose naphthalene during the air drying step. On the other hand, if it's a surface soil and has already been exposed to air for weeks, months, years in some cases, it's like, well, if you've got some of these lower boiling semi-volatiles around, then they're obviously still stuck pretty well. So in that case, air drying isn't really going to change anything because you've already had a lot of air exposure in the field.
Thank you very much. This question, I think it's going to be more so directed towards Ed. What compound is being used for the pH surrogate?
Yeah, and Mark actually participated in that. And to tell you the truth, we evaluated 4 different surrogates and we narrowed it down to 2. And Mark, I don't know if you remember the 2. If not, I can send that information later.
I don't know which 2 you selected at the end of the process.
Okay, I'll tell you what. If the person who asked that question can bear with me, we can certainly get that information. I can forward that out to them.
Yep, thank you. As a reminder, all questions will be saved as a file, and we will get any questions that aren't answered addressed after the meeting, and those will be distributed as well. So just wanted to note that before I continue on. This is a question for the EDQW. What is the DoD's position on ISM sampling for PFAS? Does the EDQW have a position, rather?
All right, so this is Ed, and then I'll invite any of our principals actually to also chime in. We have received this question before. First, a point of clarification is we don't necessarily represent DoD in this respect. Of course, we are only speaking from the terms of EDQW and our data quality concerns. As I said in my slides earlier, we do believe incremental sampling is a great tool, but proper data validation has been performed, and we're not aware of any great validation studies that have been done for PFAS. And as I said on one of my last slides, as you can imagine, and as everybody knows on this call, right now our action limits for PFAS are very, very small, and a little bit goes a long way in a laboratory. And we're processing very large samples. We're talking about dust and trays and milling, and so as you can well imagine, that we have some genuine concerns about positive bias in these situations. So at this time, we're not saying that incremental sampling will not work for PFAS, but at this time, the EDQW is not recommending ISM for PFAS until it's been further validated.
Yeah, and this is Jordan, and I'm going to concur with what Ed just said. Is the concern of contamination because of the level of processing that needs to occur, gives us pause, especially because, as Ed indicated, the low action levels of PFAS and the challenges with its analysis. So, and so I think Ed stated that correctly.
I think we also, this is Brian chiming in from the Army, I think we also have to look at what would indicate that the PFAS contamination would lead you to need to do this level of heterogeneity look as far as how it's dispersed through the environment, usually as a foam, as a liquid. I could see setting it up to do some kind of exposure scenarios, but it's not a particulate that gets laid down into the soil matrix. So doing a lot of the steps of ISM may be overkill for the way that the contaminant is actually released into the environment.
Perfect. Thank you all for your response. So at this time, I'm going to go back to a previous question we received. This one relates to the QSM Appendix B tables. Will a new table be added for EPA method 533?
I can answer that. This is Janice. No, it will not. 533 is a drinking water method, and we do not have tables applicable to drinking water methods in the appendices for PFAS. So 537.1 and 533 are not covered by any tables in the Appendix B.
Thank you for that response. We have a question for you, Janice. For the PFAS interlaboratory study for the 1600 series development, will the MDL revision 2 be applied to this method?
Yes, for the multi-lab study, we are asking the laboratories to follow Rev 2 of the MDL and 40 CFR Appendix B, 136 Appendix B.
Thank you. And continuing on the PFAS theme, when is the 1600 series interlaboratory study anticipated to officially start?
That's a really wonderful question. So we're in the process of working on the single lab study report, and the method as posted as a 1600 series method has got to be, for the most part, draft final before we can start the multi-lab study. So we're hoping, I can't give you a date, but we're hoping that it's going to be more towards the end of the summer, beginning of the fall. There's a lot of other components that need to be put in place. Like I said, we have a group that is going to be generating all of the samples that are involved in that study. In order to generate those samples and spike those samples appropriately, we need to fully characterize all of those samples prior to sample preparation, so that we make sure that the native concentrations don't exceed, for instance, the spiking concentrations, and we don't have problems with dilutions, samples exceeding the calibration ranges. So all of that needs to be put in place. Plus, we are actually going to provide the participating laboratories with the standards that are needed for this study, and so we have to generate those mixtures before we can get the laboratories started working on these methods. So there are a lot of things that need to come in, happen before we can have the laboratories actually start working on this method.
Perfect. Thank you very much, Janice, for that response. Our next question relates to the data review and management subgroup. And Melinda, I believe you've already answered it, but I figured we'd read it out loud. For the recent blank qualification rules, have you considered the common lab contaminants like methylene chloride, NEK, phthalates, etc., for extending the range from 5 times to 10 times? This is consistent with prior risk assessment guidance.
Yeah, I think if you look at those guidelines where those common laboratory contaminants are applicable, you'll see that they are described within the guidelines. And I think there even is a table of what we consider those common laboratory contaminants to be. And then it discusses the 10 times rule. So that does still apply in those. I can't remember the exact language, but it says something like, in the case of these compounds, use 10 times instead of 5 times.
Thank you, Melinda. And to continue the discussion on data validation, if a validator X flags data in the database and during the usability assessment, which usually occurs after the data validation is finished, the team decides to use the data, is the validator supposed to change the flagging in the database?
So I guess it will somewhat depend on how your database is set up. The way that it is intended is that you would have the laboratory qualifier, and then separate from that qualifier, the validator has a qualifier, and separate from that qualifier, usability has a qualifier, or however you want to call it, usability qualifier, final qualifier, whatever you want to call it. So the idea is that one qualifier is not overriding another. And no, the validator doesn't have to go back and change their qualifiers. They made a recommendation, and then that is what they are responsible for. The usability team is responsible for determining the final usability of that data. So they have their own qualifier. That's the way we intended when we wrote it anyway.
Thank you, Melinda, for that response. Now we're going back to a brief discussion on the ISM topic. If we find an exceedance at a central source, for example, sampling unit 1, within a decision unit of multiple SUs, but the surrounding SUs are less than levels of concern, does one need to clean up the entire DU or only SU1?
By the definition of the question, because I'll jump in here, you actually set up each sampling unit to be its own decision unit as well. So if you are going to set up that you would want to only go clean up the sampling unit that is elevated, then that becomes its own decision unit and would probably require or should have all the replication to understand its heterogeneity relative to the decision that we're going to make. So in that case, it's very similar to the discussion about an exposure unit versus a decision unit. If you're trying to answer two different potential questions, then you may need to look at your replication and whether or not you have sufficient power to make your decision for each organized decision unit. So a little bit of double talk there, but it really comes down to how many decisions do you want to make? If you want to make decisions on each individual sampling unit, then those become their own decision units as well. That doesn't mean that you don't need to make a bigger decision for a different reason, that you would then take each one of those individual sampling units and combine into that larger decision.
Thank you very much, Brian, for that response. So we have a question here relating to the QSM Appendix C. Are there any plans to reevaluate the LCS studies and establish new LCS limits that may be more representative of DoD accredited labs and procedures?
So Matthew, I can take that question. At this time, there are no plans to redo the LCS study in Appendix C. What the plan is, once we roll out QSM version 6.0, where the Appendix B tables will most likely be revised and have new or different criteria in them, we will give those tables some time to be implemented across our DoD ELAP laboratories. I'm thinking at least 18 months to 2 years for a full accreditation cycle. And then at that point in time, we may reconsider doing the LCS study.
Thank you, Alyssa, for that response. And now what I believe to be our last question, and probably a very important one, where can we register for the usability and validation webinars? And I'll go ahead and expand upon that. So shortly after the conclusion of this webinar, you all should be receiving a save the date for the data validation webinar that we have upcoming, which is scheduled for June 30th. Following that, keep an eye on your emails as we'll be sending out the registration information just as we did for this webinar. So it'll follow that same process where you'll receive the invitation email, you'll register, and then you'll receive the official registration confirmation that will contain your calendar invitation. And at that point, you will be all set once you've registered. So with that, I believe that concludes our Q&A section. Jordan, do you have any closing words?
Yes, Matthew, I just want to thank everybody for their attendance and thank all the presenters and speakers for their presentation. And as Matthew said, filling out that survey is really important and only helps us. And I look forward to a better year ahead and seeing everybody in next April in sunny Florida. So everyone have yourselves a great rest of your day, and thank you for your participation.
This is Alyssa. I do have one extra thing to say. If you could please take a moment of your time and fill out the survey, it really does help us plan for future webinars, and we do constantly want to improve as well. So thank you for doing that in advance.
Thank you all, and this concludes the first part of the 2021 EMDQ workshop webinar. Thank you all for stopping by, and stay tuned for more information on upcoming events. Thank you all for staying in, and have a great rest of your day.